Hi, one moment here. Because, oh, cool. Doing fun stuff. I love it when that happens. Good job, Internet. Yay. Okay, hold on.
This is a deck talk test.
Okay.
This is a deck talk test. Deck talk is now online.
End of line.
All right. I didn't hear deck talk. I don't know why it didn't work, but all right. Okay. Hello, everyone.
BALJEMMEPT says Awoka. Unexpected double-length Friday stream in the banking area. CHEER 100.
End of line.
Woga. Hi, everyone. Okay, so real quick, not going to be able to stream tomorrow. So we're doing early stream that's full length today. You know, try to make it work. So that's why early. So yeah, there's not a whole lot else there. We do have a bunch of stuff to do. First, I'm going to mention that I finally got a solution for storage. Check that out. That is a U-line double drawer, like super wide file cabinet that I'm putting, well, stuff into. Okay, that's not gonna work. So yeah, I'm working stuff into there for storage. I feel like that's gonna be way better. And when I say working, I mean, work is ongoing. So that's that. It's like a $10 file cabinet, yeah. But also there's this thing. Let me grab that here and I'll show you what I have going on there, because I'm doing a thing that, you know, sensible people would have done like a decade ago. I am finally organizing parts. So, I was against getting these for a while, but two things happened. One, I realized I am over-ordering capacitors again, so that I have spares, and that means that they have to go somewhere, and just leaving them in the bags sucks. So I wanted to start getting them properly organized. And turns out these can be had for $22 locally, which is about half as much as if you bought them online. So I'm going to start snapping a couple of these up. So I might grab up to 3 of these shortly. So there was only one available there at the moment. So yeah, got that starting to happen. So I have electrolytics up top here. I have SMD caps down here. And then down at the bottom, I got some other stuff. Oh, and then up here, we have reefa replacements, which we're gonna need today for this. So, only 3. So this is a lot of drawers. I don't remember, 6 times 5 times 6. So 36 drawers? That sounds light. I thought it was like 60 or something. Anyway, it's a whole bunch of drawers, okay? So I only need so many values. There are many things that are going to go in these, and the reason why I need more is for stuff like this. So here are some transistors, and 6x10. Counting's hard, Kay. I want to talk about these in a moment in particular, because I've had those for a while, and I think we have a good use case for them. So we're going to do, well, I'm going to do organizing of this. I just found these while I was continuing to clean up some more here. So these are going to get organized into there at some point. I did want to ask, because I don't remember, because there's too many things going on. Did we try and recap the Toshiba T1600, the beige Toshiba laptop that looks like it was made by Play School? Because apparently I have all the caps here, and I don't remember if we did or not. I thought these were the caps for the Coleco Adam stuff, but no, therefore the Toshiba T1600. So yeah, I might be organizing those away. I'm not sure. So there was one other thing I wanted to talk about. Oh yeah, it was this little thing right there. Oh, what's that? That's new, ain't it? Yeah. So that is something we'll talk about later. So if you want to know more, you have to stick around, because we're going to do the power supply first. And if I start on that, we'll never get to the power supply. But there's fun stuff. All right. Been playing more bookshelves for the front room. Let's redecorate. Storage is good. Organization is where you fall down. Yeah, so the organization part's where this is going to be difficult. I've been hoping to find RF Programmer. Hello. I don't know what your availability is going to be like, so we'll sneak peek into a little bit of this here. Okay. I have acquired many things, none of the ones that we actually need, annoyingly. So first off, Thor Labs 100 should be here all evening. Okay, I'll start with this, and then later, after we fix this, we're gonna go into signal analyzer stuff. Thor Labs has a 3-week lead time on the EF500. It turns out I believe they had it listed as available today, but then I guess when they went to go get one off the shelf to send me, it turned out there weren't any. So I have an invoice that's 100% discount. They will send it and we'll be able to test it. But I don't have it today. Also, I don't have any 50 ohm terminators because Amazon decided, nah, you don't need those. So, but I do have a bajillion different random BNC adapter things here. So I figure we can like doom one of these and solder a 50 ohm resistor on it. So we can do some stuff, I think. So hopefully we'll be able to do some things. I have also read through the first, I think 178 pages of the Spectrum Analyzer manual. I now know how it works. I know how to use it. I understand what all the buttons do. So, hey, I'm pretty happy with that. So as far as I'm aware, the SIGGEN, I could use, oh, spoilers, that's what that is. I could use KJ's colors now, yeah. The SIGGEN, I could just direct connect to the 50 ohm terminated input on the Spectrum. As long as you don't destroy it, I'm happy. Yeah, that's my goal. So because I don't have the terminator, I think I could just plug it into the 50 ohm terminated input on it. As long as there's no DC bias on the SIGGEN, it can do DC, which I'm not super thrilled about as far as like this stuff, but we could measure with a multimeter, make sure that it's off and actually off and not poorly calibrated or anything. So, or we could try and make a ghetto terminator and use it on the 1 meg input, I suppose. So yeah, it's very interesting. Oh, so for those of you who aren't in Discord and we're here for the end of the last stream, okay? So let me explain what happened with the SIGGEN. I plugged a cassette player into it. I did have the volume turned down really low on the cassette player. And there is an overload light on the Ghetto Sounds Better. Okay, we'll go that for now. There's an overload indicator on the front of the spectrum analyzer, and it lit up when I plugged the cassette player into it. Now, I didn't know how the spectrum analyzer worked then. Now I can tell you that what the overload indicator means is that the signal is being clipped at the top of the analyzer. It means it sees, yes, Helen early stream. We're gonna go the 4 hours that I would normally do on the weekend because I can't do a stream tomorrow. So a full length stream today. Anyway, it's clipping the top. It's overdriving the signal. And the manual states that it will not damage the front end of the machine unless you go over, I forget what it is, like 12.65 volts or something RMS on the input to the signal analyzer. So it was never in any danger because I don't think we're gonna get 12 volts out of a cassette player. And I actually had it plugged into the 1 meg impedance input, which can do 42 volts peak to peak. So we were super duper good. What it was telling me is that we were clipping the signal, so we weren't getting it fully captured. That's what it was trying to tell me. Now, interestingly, the manual actually talks about why overdriving can be good, and it recommends doing it in some situations so that you can get a better signal to noise ratio. It's crazy. That thing, it's insane. So yeah, I'm much happier with where I'm at now with it. When we go to test it, I'll say that the SIGGEN I've read the entire manual for, so we should be able to do a bunch of stuff. I actually read the entire manual before it was even delivered. So yeah, all right. For right now though, we're getting this thing back up and running. So let's enjoy my videos on YouTube. Well, thank you, Fat Wookie. Also, I don't know if I said it, but Ben, thank you for the 100 bits. All right, let's continue, or go back to this, I guess. 12.6 VRMS, that's a massive signal. It says 25 dBm. I might be wrong. It would be worth double checking the manual. I would double check the manual, but I don't have to it yet. So I know it is insane and weird for SA. If it would be a car, it would be the car min speed of a snail, max speed that of a golf cart. Let's see, it says max near the plug. Oh, does it? Yep, 13 volt peak to peak. So yeah. Yeah, I don't know. Is it just because it was so early RF programmer? I am not sure. Interestingly, okay, I want to get this thing done, but I also want to nerd out because I read the whole manual, so I got like things to talk about now. So this has what's called manual mode in it, all right? And you put the marker on any position to just get a real-time amplitude reading of any single frequency. And as I was looking through the HP catalogs, I noticed spectrum analyzers that were nothing but knobs and a 7-segment display. So before the CRT-based ones, I'm guessing spectrum analyzers were literally just a super heterodyne tuner and an amplitude reader, which is kind of weird. And I don't know how much time there was between that and this thing, because that could explain why this thing is so weird. I have a feeling this is really close to those. Now you have a device with fast ADCs that can do the job. Yeah, no weird applications. Okay. Yeah, I don't know. 40 volt max in front of HP analog device in the same era here, so that seems where HP kind of went with it. So that's for the 1 meg impedance input. Yeah, it is, man, it's crazy. We should get this done so that we can actually mess with that. The other thing, okay, unrelated, okay? Not related to any of this stuff, except is 100% related to this stuff, okay? You guys remember the foot pedal? Did 2 things with it. The video about UW programming on Linux, and then I set it up for doing hands-free scanning initiation with the A-Vision. I own another one of these now, so I'm going to bring that to the office. I actually found one new in box. It was kind of weird. Anyway, I realized I want this over here. I'm going to put it on the floor, and then I can tap this to essentially redeem edit mark on streams. But also, I had a realization that if I program it so that when I'm holding one of these, I could have the GPIB monitoring software pause accessing the devices, and then I could do whatever I needed on the front panels for however long I needed to, and then I could lift and then have it resume querying them. So the devices like the 34401A that are a pain, or the 6633 power supply, I could alleviate the issues with that by just having something that I could hold. So I would just have it on the floor and then step on that, and then I could do whatever I need and then release my foot and walk away. Sounds like a good idea. Yeah, I'm thinking that that would be kind of optimal. So I doubt we're going to have time to get to that this weekend, but that is a goal. I am early today, Dutch Black Cat. We'll almost certainly be adding the edit mark stuff early, though. We might do that tomorrow. I don't know. Or not tomorrow, the day after. Well, maybe I do it tomorrow while I'm off stream. Anyway, I don't know. This weekend, I want to add the edit mark thing. How come I'm not streaming tomorrow? I just schedule conflicts I can't. So, all right. The very early days for kicker surface or mechanical devices, use those instead of... were mechanical devices used instead of those sorts of spectrum analyzers. Okay, interesting. Let's see, foot pedal with USB. Yes, it is a USB Infinite something or another. I don't know. You can go on my GitHub and see the USB device ID because I have it listed there. So think you need guitar pedals for Death Clock vibes. Yeah. So it was for some of us get home from work. Yeah, it is very early. All right, let's actually make progress here. Where is the screw container bin for this? I don't remember where I put it. It should be very close because I did just work on it. Oh yeah, the other things. This is kind of for our programmer. I bought a bunch of garbage capacitors for making filters. I got BNC paired jacks. I have 6-foot BNC cables. I got 3-foot BNC cables. I've got perf board. I've got these are the BNC to banana jack adapters, and then these are solder lug BNC, or not BNC, banana jack discrete connectors. And then the, like, every possible combination of BNC to SMA adapters. I am missing the terminators, and I am missing
CHER 500 end of line.
Dr. Doobie, thank you for the 500 bits. I really appreciate that. I'm missing solderable BNC connectors, and I think particularly Desiac for some reason will get a kick out of this. So here's the idea I had, okay? I want to be able to design my own filters and probe module things for the spectrum analyzer to be able to do stuff. So like, I thought it would be a good idea for an initial start to make a high pass filter that has its knee at about 100 hertz so that we could eliminate AC line frequency. So the way that you do that is with an RC or LC filter, and then you figure out, you know, math, that whole thing, what resistor and capacitor value you need. So I got perf boards, we'd solder those to that, and then I don't have them yet, but you would put BNC jacks on the end, build your own termination, use 2 100 ohms, not 150 ohms. Oh, to get higher precision? That's a good idea. Cloning Moog LPF? No. So there's 2 things that I wanted to do with this. Oh, let me just look real quick in this drawer to see if I was right about something. If it's not here, then it's down below. It looks like it might be down below.
CHER 100 a good idea. What's one of them doing around here? End of line.
Thank you for the 100 bits. Oh no, don't tell me I was wrong. Wait, is this it? I thought there was more of it. Oh, I might have been wrong. Oh, well, drat. Okay, if I was wrong, well, I need to dig around more. So this is EMI shielding tape, okay? So if you're building like a really sensitive filter, you need to wrap it in this stuff after the fact. So I had this idea. I was like, I'm gonna get perf board, all right? And then I'm gonna build my circuit, I'm gonna shrink tube it, and then I'm gonna 3D print closure, but before I put in EMI shielding, that way there's an insulated layer, and then I can put the case on it and put like a label or something for that. Fun fact here, I finally decided to try getting a beige filament. Check that out. That stuff's like perfect color. I am extremely happy with that color. Let me give you a reference here of some kind. Let me just find a beige thing really quick. The encoder did not like your attempt to mimic James May's cheese gif. That was filament. Oh, dropping it down. Yeah, it seems to be unhappy about that stuff at the moment. What's here's a floppy drive. That is an extremely yellow floppy drive. That's not a very fair comparison. Okay, here is a slightly 1/4-inch drive. Look at that color. It's such a good match. I'm so happy with it. Anyway, what brand filament is it I needed now? So it is, I don't know, matte PLA. The color I think was listed as khaki. Here, let me see if I can just share the link through Discord.
End of line.
It is indeed, I'm a cat. Here, I'll just share it through Discord really quick. Yeah, I'm pretty happy with the color. Anyway, here's the thing DZAC will like, okay? So I said I wanted to shrink tube the...
5 EHE4 S2 says CHEER 100. It was time for drastic action. Epoxy. No. Beige filament. What? Good morning all. End of line.
Jason, thank you for the 100 bits there. I'm a cat. Thank you for the tier 1 sub and for 35 months there. I really appreciate that. Hold on, just trying to get the link. Share. Sure, yeah, okay. Hold on. One moment. One second, I gotta obey Amazon's rules. Here is a link I make money from if you click and buy the thing. There you go. Anyway, yeah, the beige filament looks really good. All right. I didn't mean to tease it, okay? I wanted to shrink tube this stuff, so I thought, like, I don't know how wide I want the shrink tubing to be, so I figure, like, 4 inches would probably be good because it's like a 2-to-1. It'll shrink down 2 inches. There'll be stuff on it. I bet it's going to be about 2 inches. This is shrink tubing. I think I bought the wrong one. It's big enough I can put my arm in it. I didn't even know it came this big. So yeah, I could shrink tube it the wrong way. Anyway, I just figured, I guess it would seem interesting for car stuff, so DZAC would be interested, because, I didn't even know you could get it this big. You say have that in the bin of fries? Yeah, it's giving you bad ideas. Yeah, I didn't even, jeez. So now I gotta figure out how to make those long gloves. So the other thing I have coming, which is gonna be about the same size as this, I bought that before I bought the 3D printer filament and had that idea. You know how, hold on, I can just show you this. Let me put this floppy drive away and I can show you the thing. Because there's one right here. No, that's not it. Here, there it is. Okay. This is
says Happy Earth Day. End of line.
It's Earth Day? I did not know. Cool. This is a battery cell pack. You can just get this shrink stuff. This is just like a PVC shrinking things. So I got some of that too, because initially I thought I was gonna wrap the perf board in the shrink tube, put the EMI tape around it, which apparently I'm gonna need to buy EMI tape because I don't think I know where the spool is for that. And then I was gonna put this over it, but then I realized I could just 3D print an enclosure.
100 happy ground day for the Americans. End of line.
Brief Relief, thank you for the Prime sub and for 10 months there. I appreciate that. And Claude, thank you for the 100 bits. All right, 48 to 60. $20 volt and 0 to 50 volt at the highest outputs. Is that perf board with ISA edge? No. It's just a regular edge on there. I wanted the edge one so that I could solder like solder lug stuff. Oh, I did find this actually. We might be able to make one 50 ohm terminator because I found a single incorrect gender BNC jack. I have no idea where this thing came from. So I might be able to just solder, I guess, two 100 ohm resistors there. That on the end of a T or something. I don't know, but that's an option. So yeah, if I ever shut up and actually fix this power supply, we might even get to do that today. Being for medium voltage conductors. Oh, it says 1 kilovolt on it. It came from UX Cell, so maybe that's legit. Yeah. I'll go over the last final thing before we actually start here, because I can't help myself and I'm a child. There is one other thing that I want to make in addition to the high pass filter. I want to make an amplifier. This is not for the signal analyzer, so don't worry about that. I want to make a 50 ohm impedance to like high power output, where the signal analyzer goes into a box along with power from one of the power supplies, and then the power from the power supply is emitted through the box using the signal as the full scale output. So what I have, which might be applicable for this, are some TIP 120 Darlington transistor packs. Now, I've had these for a while. These are high current transistors, and I think I might be able to use one of these to make my amplifier for the output of the signal generator, but I gotta figure that out. We're definitely not getting to that today, but that is a thing that I want to try and do. So that's another project. But again, that's not spectrum analyzer at all. That is signal generator and power supply only. So the power supply had a high voltage output option. This one was not equipped with that, but it doesn't matter because it's only high voltage. It's not high current, so you can't use it as a power supply anyway. So I'd really like to just offload all current from that. Anyway, okay, let's finally actually look at this thing. Only 30 minutes in. We're making great time here. Okay. This is an HP 6624A. This is a benchtop programmable power supply that has 4 output channels. Now, you can get this configured in several different ways. This is what I would consider the ideal configuration. The 4 outputs are geared towards high current, low voltage, and low voltage, high current. Now, the total power output of this thing isn't that high. To give you an example, 20 volt at 2 amp for one of the low ones, and then 5 volt or 50 volts at 0.8 amps for one of the low ones. That makes the total power output of this to be kind of just about the same as the other 2 power supplies that I have over here, but added together. So it's not super high power, but it's not a slouch either. Now, I wanted this in combination with the other 2 power supplies because I wanted to be able to build multi-voltage cable harnesses. So like ATX power supply, I want to be able to make that ATX plug that's powered only from benchtop power supplies so that I can control the voltages coming into a motherboard and then handle all of the discrete voltage rails. The one thing I can't really do is negative voltage rails, but those aren't super common on modern stuff, and they're needed on older stuff, so we might be able to get away without that. But this should allow me to make pretty much any set of voltages I need, and the different outputs on this will allow me to also have like control signal voltages for different things. So I will have 6 programmable power supply rails, 2 really grunty ones from those that are 100 watts each, and then the total like 50-ish watt channels from this. So I am really excited to get this thing working because it will complement the other 2 power supplies very well. The only downside is you're probably looking at the front of this thing and thinking, where's the power come from? And that's because this era of HP power supply has everything coming out of these screw terminals on the back like this. It's very annoying. I don't really have a good solution for this part yet, so we're not gonna go too hard on like actually testing this today because I mean I'm missing some screws. Yeah, I don't know that we're gonna get too far on that part. I do have banana jacks we could make cables with, but I don't have a ton, and I would have to dig around a little bit more to find. I have a DC joiner block, kind of like this, that allowed me to join cables in and out from this to banana jack cables. That's how I utilize the other power supplies. But for right now, we're just gonna try and get it going and test it out. So outputs are floating, so you can just reverse one for negative 12 volts. Oh, if they are floating, maybe. You're right, Wizard Tim, maybe I could. That would be nice. If I can do that, that would be sweet. Well, yeah, so the old one, they're no longer part of the ATX power spec, but when do I work on things that are current? Well, let me rephrase that. Contemporary. The whole point here is that it's current. Okay. So, let's get this thing open so we can take a look at what it is exactly we need to do. So, all right, 3D print 9.5 rack frame with a bunch of holes so you can mount banana jacks in. Maybe, am I proud of that joke? System style PSUs always have outputs and terminals on the back. They're designed for fixed installations, not benchies. Yeah, that makes sense. The ones that I have over here are weird. One of them has jacks and then the other does not. I can feel underneath this label there are the punch outs for the jacks. I mean, that's not surprising. But this one had the option for that. This one could have had. I don't know if that was an option on this. I kind of wish it was. But yeah. Suppose patch bay would be the solution? Yeah, that's my plan. So for those of you who don't know, well, I currently have it tucked back there and kind of have the cables dangling in a weird way, but those power supplies I use basically just like this does, even the one with the jacks in the front for the most part. Okay, this thing is crazy. So I mentioned that you could get this configured different ways, and you do that by having 4 different power supplies in a box, essentially. So we have 4 discrete power supply modules in here. And then we have one massive transformer and then a small control board for the, okay. The GPIB control video has very controversial comments in it about what the pronunciation of GPIB is. I would just like to point out here, this is an HP, technically Agilent device. GPIB, all right? So even if it's HP, can be GPIB because they released it as an open standard. And then GPIB versus GPIB. I'm never going to say GPIB. That's so stupid. So yeah, I'm going to call everything GPIB. Don't care. All right, just call it IEEE 488. Yeah, because I'm trying to save syllables, so calling it that is going to save it so much time. JPIB. Oh, man. Yeah. Call it GPIB. See, I can get that, but I'm going to call it GPIB. It's just, I'm never going to call it GPIB. That feels so weird. I don't say, oh, this is an SCSI hard drive. It's SCSI. Now I do say it's an IDE hard drive, not a ID hard drive, but it's just, But I'm going to call it GPIB. Oh, well. GPIB, yeah. All right. So why do we have to work on this thing? Well, it's chock full of reefa caps. So here's one, there's one, there's one, there's one, and that's one module. Multiply that by 4. So there are 16 reefa line filter capacitors in here. We're going to replace them all today because you may have noticed that I mentioned that you have the giant transformer and then the HPIB, GPIB module. I will admit HPIB sounds very, very wrong because it would be HPIB. That I can get, but GPIB. Anyway, these are their own discrete power supplies from probably down voltage, not line voltage. And I am pretty sure that the reefa caps are in critical paths because, well, for one, this is the output. Those are reefas right there. This over here is the transformer input. So yeah, there's no way it's high voltage all the way over here and then back for regulation and then out to this. So these are critical. So we're gonna replace all of them. And yeah. So, sure they're fine, just turn it on. Oh yeah, what's the worst that can happen when 16 of those go off? Pretty sure I have turned it on, but yeah, we're not chancing that anymore and we have to. So, I got one other fancy thing to show off because we're gonna need the desoldering gun today because that's a lot of solder in there. And I just wanna show this off. I don't even know if you guys can hear this actually. Desolder gun, air gun. I got a manifold for the air compressor so I can run both of them at once now. Also, okay, every time I use the air compressor, someone chimes in like, oh, make sure you drain the water, okay? First off, Arizona, there's no water in here. Second off, I actually thought, you know what, it's been like 2 years, maybe I should actually try. I went to open the drain valve today and it broke. I had to completely disassemble it and rebuild it to get it to actually seal, or I wouldn't have been able to use the air compressor at all. So guess what I'm never doing again because I live in Arizona. It rusted off. No, there is a cap like nut thing that goes into the tube that has a nylon ball fitting on it, and then there is the ball valve that rotates with the hole in it so you can let the air through or not. And the ball valve had shifted and it was leaking over the top of it. Did any vapor come out? No, nothing came out. It wasn't wet at all. It was just cold because of the air rushing. So no, nothing came out. I even cracked it all the way open and tipped it over in case it was just like a puddle in the bottom. Nothing. So put your compressor in another room so I don't have viewers listen to it running. So I would instead just bought like a super fancy quiet airbrush one so it's not that loud. But yeah, leave your compressor off, doesn't build up any condensate, and you're in Florida. Oh, you leave it off, condensate. I think that people are saying it's the compression of the air into the tank. It like liquefies the water vapor in the air. Anyway, it doesn't matter. I'm in Arizona. So typically he'd have a noise gate that hides it. Compared to here where my compressor same size will throw out a tablespoon of water with 10 minutes of running. Wow. California air super quiet. Ah, weird. Okay. So average Arizona ever seen a body of water before? We have fake lakes. They're in the golf courses, you know, a very good usage of water. There are so many golf courses around here. It is obscene. Anyway, let's continue on here so we can play with the fun stuff. Not that, this isn't fun, but it's not signal generator and spectrum analyzer fun. So, all right. I did take off one of these boards because I wanted to make a proper Caps Wiki page so that I could measure the pitch of the parts and everything. So I do know how to do this. So let's go ahead and start by pulling these ones out because I didn't actually do the inner ones yet. So just for kicks, that'd be different to go ahead and try. I still haven't found the screw container for this thing. Where did I put that? The case is over here. Maybe it's by that. No. The case has the handles in it, so at least there's that. I kind of need it. Where'd I put it? Oh, there it is. Lake Pleasant is real. How did you not go Lake Powell? The one from Hydro Thunder. But that's way up in like the mystical land of Flagstaff where there's like snow and stuff, so that doesn't really count. They don't sell that beige filament at the local Amazon? Oh, that's unfortunate. All right, let's get a power supply module out. Thankfully, all of the connectors here are keyed, so this is pretty easy to work on. Don't have to like Sharpie marks onto things. So I can just wholesale unplug whatever I want. It will not matter. Also, okay, this is weird. The GPIB control cables that go to the individual power modules are literally RJ11 phone cables. Just routed inside. I wonder what the internal bus protocol is. Is it I2C? Is it SPI? Is it some differential? Because there's 4 conductors. It's weird. Serial? Maybe. It might be RS-232. Stupid stainless steel screws. Oh, it's not. Okay, never mind. I'm just bad. This was a good call by HP. So these screws in these plastic tubes that run through the heatsink, that way the heaviest possible part is discreetly mounted to the chassis. That will prevent, or help prevent, I should say, the solder joints for the parts on this from cracking. So that's a slick move right there. All right, then you just slide this back and then kind of hope you can figure out how to get it out because like there's cables and stuff in the way. So it was easier on the other ones. Oh, don't mind me, I'm just using this X-Acto knife to press these vinyl sleeves away. It's a really safe tool for this. Oh my gosh. Yeah, I don't like the bending of the power supply board either, but like, oh my gosh, it's so jammed in there. You know what? I have an idea. You're coming with me, cables. Oh, now it's getting jammed on the ones on the side. I need to get it up enough so I can slide it. But, oh man, it's okay. Nope. Okay, up, out, forward. Stop it. Forward. Just go forward. There we go. Whew. Okay. Wow. That sucked. Those ones aren't like anywhere near as bad to get out. Jeez. Oh, okay. What's the problem with this supply? It just has reefa capacitors in it. They're not like known bad, other than every single reefa is suspicious. Actually, I was going to use the fume extractor, but like, why? Okay. I am heating up the desolder gun now. So nice to have that permanently routed now. Don't have to worry about that anymore. Oh. Soon by two matching power supply boards. Yes, so this has, excuse me, the two 50 volt and two 25 volt or 20 volt. They're mounted diagonally from each other for some reason. I don't understand, but you know, they are there. All right. Does anyone want to go back to one of the office vlogs when I first got these and see if I did actually power this on? Because I'm now wondering if I should do a quick reform on these caps. Because they're kind of big. I am not set up for capacitor reforming right now, so that will be a thing. These will be fine. So they are 27,000 UF 16 volt, 12,000 UF 35 volt. So a little big. They probably will be fine. You're old and blue, yeah. All right, one moment. I'm just bringing up the Caps Wiki page I made for this because I believe that will have my photos so I can rip these out without having to pay attention. Yeah. Didn't we think there was much point in reforming low voltage caps? It's still high power. So the problem with the low voltage caps like this is there's so much capacitance that it will be able to draw in that much power, and it could still blow through the dielectric. So it's more about total power. Like a high voltage cap, you have more dielectric to lose, less capacitance to draw the power in, but you have more dielectric to lose. But for these, it's more about how much power it could draw through the lower dielectric voltage rating. Out of curiosity. Sorry if you hear my Windows 98 video in a second. Okay. I do want to check the Office vlog, see if I turn it on. Just put the whole PSU on the Variac and power it with like 80 VAC. It's a switching power supply, I think. I mean, maybe this is all linear. I don't know. Shouldn't the PSU be set up to charge them slowly anyway? Why would it? That's not a like needed feature. Okay. All right. Office vlog 4. Good. Hold on. I'm going to shut this nerd up. I'm going to look and see. Did I turn them all on? Did I turn any of them on? I may have never turned this on. I have never put power to this thing. It's a linear PSU, nothing switching. I'm willing to try it because I kind of do think you're right. Probably isn't necessary to do it on this. But I would like to, this is what vacuum cleaners exist for on the floor, by the way. I would like to, okay, that was more than I thought it would be. We won't do that for the second bottom one. The top ones are fine. I would like to try the Variac, and if this is a linear power supply, then this will be a good one to do this with. So hold on one moment. And I believe Wesley is here, so get to finally see that happen on stream. Now, quick question for those of you who are electrically inclined. Variac, is that also an isolation transformer? Because I'm pretty sure the answer is yes, but just to confirm, is it also an isolation transformer? Nope. Maybe it won't isolate. Okay. Well, I'm glad I asked. Not that it really mattered. Almost all Variacs are auto transformers. Yeah, that makes sense. On that, so auto transformer. Okay. Wow. Okay, Wesley, I tried to peel off the sticker and I couldn't, and it shattered my thumbnail. Sorry. You remember my super sketchy 250 volt, 240 step up transformer that I got that was made by toddlers in China? And I don't say that as a child labor thing. I mean as in a skill of the assembly kind of thing. Could I wonder if I could convert that to an isolation transformer. We'll never forget that mess, yeah. But I'm wondering, I don't remember if there's a 1-to-1 coil in there or not, but I think there should be. So I might be able to make it like a 500 watt isolation transformer, I think. Anyway, Variac. Ugh. Rated for up to 15 amps maybe. So yeah. We were talking about breakers and fuses and other stuff for like testing power equipment. It turns out you can get breakers that fit in this. So I might get a breaker switch that goes into there. Because I was talking about maybe drilling out a hole in a Variac like this, but if I could just replace this with a switching breaker, I feel like that's a win-win. So for any weird new stuff that I test, I can just crank this all the way and then turn that, and then bam, I got a breaker built in. So I have to rewind the transformer. The Advantage Auto Transformer is using less windings. Oh, that's right. It's single-sided. Yeah, never mind. That won't work. CPU doesn't start the PSU being in an unstone state. It may not like brownout conditions. Yeah, that's kind of what I was thinking. Because it is not... It's not nothing. It might also... Well, maybe not with these. What are those? Those are 50 volts. These may be for output. Or these, I should say. So it might be that it'll all start up on 0 and then I can just slowly ramp them up. Oh, that's gross. I never looked at this before. There's no buttons for like this channel, this channel, this channel, this channel. It's left or right arrows. HP, that's terrible UI. Or UX, actually. We don't need a CPU to charge some caps. As long as it lets power through, yeah. All right. Let's yoink some reefas. This thing will be fully heated now. All right. Let's also let the air compressor actually fully charge. All right. Getting started proper now. So... here, there, and there. Oh, I did have a question, mostly for Helen Croft. When we were working on the Tandy 1000RL and the power supply, how did you immediately identify that green resistor as a fuse? Is it just that it was green, which meant it was like low current or something?
Chloroku says CHEER 100 skill. End of line.
Skill, yeah. Green dull color is frame resistance and used for fuse applications. Okay. It was in circuit and fireproof, yeah. Meant to control it with HPIP anyway, yeah. Oh, flame resistance. Okay. Interesting. Okay. Yeah, whatever solder's in here sucks. Oh, come on. Just fall out. There we go. Yoink. Code green also gave it away as 3.3 ohm. Common fusible resistor. All right. I was just wanting to add that knowledge so that I can identify that in the future. Doing electronics for 20 years. Yeah, that's definitely the kind of thing where it won't make sense without knowing. So I appreciate you letting me know that. I wonder how confusing it is to the people doing construction next door that there's some dude in an office running an air compressor. Or maybe they just don't even think about it because they're used to that. It's like that one didn't even melt. Man, these ones suck. Could also been gray with same texture. Okay, good to know. The resisting rest. In modern stuff, they can also have heat shrink on them to contain the pop. Okay. I assume they're like way cheaper than an actual fuse or fuse holders or something. And that's why they would be used. There we go. Jeez. Not really. They blow faster. Okay. Come on. There we go. So these ones, for a condition assessment, are actually in really, really good shape. That one, not so much. No, not that one. This one might be the best looking Rifa I have ever seen. I'm not sure there are any cracks anywhere. That's kind of weird. frame it. Yeah, no kidding. As you hit freshener refills, yeah. All right, got one more to yoink. Right there. Looked like it might not blow. Yep, but might not. So, bye-bye. This one probably wouldn't blow, but yeah. Also, when I ordered these, I was all Mr. Fancy Pants Smarty guy, and I ordered them for the 3478A as well, except I screwed up and ordered a value 1 decade too small. What's annoying is the one that I think I'm removing right now is 1 decade too high to go into the 3478A. So I just barely don't have caps that'll work. Danger of being Mr. Smarty Pants ordering caps? Yeah. That's why we have the Variac to hand. Yeah, just average them out. Yeah, that's how that works. All right. So now we break out the bin. Oh yeah, I have no idea where this thing's going in the long run. Wow, that really makes it obvious that the camera is at a crooked angle, huh? Okay. High frequency HC couple PSU ground to lower the MC. Yes. But I don't think that's what they're doing here, since they're going through a transformer that already has a different line filter cap in the actual plug area. So I don't know what these are doing. Maybe make sure that the ripple doesn't go back and influence the other power supplies. So hook them across the Variac and dial it in. Yeah. Okay. We need caps. So we need one 22 nanofarad cap here. Yoink. We need one 15 nanofarad cap. And we need one 2.2 nanofarad cap. This just feels wrong to like have this all nice and organized, doesn't it? That's not how this works. Not supposed to be able to just reach up like, oh, there's the parts. So here, all the noise on National Power Grid is originating from Tech office. Remember the outputs are floating so they don't have high frequency filters? Yeah, that makes sense. All right, so, wait, I said there were 4. 1, 2, 3. Oh, that's one. I think it's another 15. No, another 22. All right. Yeah, so 22, and then 22, and then 15, and then whatever the other one is, 2.2. Okay. Might think twice before being held hostage and organized. Yeah. Move to a new office, have to be in the Mauser warehouse. Oh my gosh, that would be insane. I would be so happy. All right, now I just swap the Metcal over to the handset and be glad that the Talon is not plugged in as it falls onto the floor. And get cracking on the reassembly. So disappointed you didn't use the label maker? Ah, that was intentional. Do note, I did not write on any of the drawers. Every single one of those that has something on it has a piece of masking tape over it. And not only that, because it is a nice smooth surface, it is erasable. I put a part label here and then changed my mind, use a dry erase marker to write over the Sharpie and then just erased it off. So you can barely see there's some little marks here and here left from where I had originally marked something, but that makes it easily switchable. And I did that because I was starting to put SMD caps in there, and then I realized SMD stuff doesn't have any labels on it, and I should put the bag in there so that in case, you know, the label something happens, I would have the actual information of it. So yeah, That is intentional. And also, there are 2 values per drawer, because this is a real big drawer. What have you done with Shelby? Okay, soldering. That's it. Okay, so this goes here. Oh yeah, we're gonna have to trim legs. I forgot about that part. Actually, you guys probably want to be able to see this, not in the drawer. RW, not worm drawers? Yeah. Part of that is, you know, stock may change, so I might run out of a part, not be able to get more of it, and I don't need to just leave the drawer empty there and labeled for that part that I can't get more of for the rest of eternity, so I'll just, you know, wipe it, and if I get more of the part, just relabel it. And also, maybe, normally I keep, let's say, 35 volt caps in there, and then I order 50 volt caps instead next time. I want to be able to change the voltage rating that's listed so that I know what they are from the front of the drawer. And breaking out a label maker for that every time kind of sounds awful. Let me bring the trash can. Oh man, there's so much space now. I can't reach the trash can. Oh. It's getting spooky. There's been a spare desk, visible floor, now organized component drawers. Yeah. J11 has 2 optos next to it. Must be serial, 1 for each direction. Ah, cool. Okay. Did I just... No, I did not lose the trimmed legs. These are too short to reuse, so... To the trash. Okay, back to the Caps Wiki page here. Okay. All right. I'm going to pop these in from the front. And, you know how I say, oh, I wish I had this thing for this stuff? I found the thing. It is poster board putty. So we're going to use this to hold the parts in as I do this. So this is the 15, I believe. It is the single one, and then the 2 22s go right next to each other. And unlike HP, who are animals and put them in going the wrong direction there, look at this. That's just HP. You disgust me. I'm going to put them in the same direction. Oh, wait, this was Agilent, so it wasn't HP. So we don't have to blame HP for this one. Not that you can tell because the labels are embossed, not actually printed, so. All right, so let's take that one. I'm just going to wedge it between this resistor and that thing. And take the big one. Just stick it. Right there. Now I believe, beautiful. Text readable in the same direction, all the reference designators. As all the references on the silk screen, ref des are under the caps. I didn't pay attention to what direction the ref des were without the caps on. We'll have another opportunity in a little bit here because we got 3 more of these to do. All right. Edge of the board has text. Edge of the board. I'm not sure what you mean. All right. One moment here. I want to make sure I don't leave any little bits of solder. And I did get some on there with the desoldering iron. Okay. Should maybe not put the X-Acto knife into the random parts bin. Seems slightly dangerous. Okay. Wait, what's this random cap? 100 UF 35 volt. I don't have that up there yet. Drat. Oh, that one was on the deck talk for power smoothing when I thought that was the issue. Then it turned out it was just line frequency interference. So we put it on the transformer that I think Ben got for me. Okay. Trim the legs. Standoffs are high enough that that might not actually be necessary, but I mean, seems pretty obvious, although that thing sticks down really far. All right. Having organizers with all the drawers marked miscellaneous. All right. Wait, can you even see me when I'm sitting at the stool with the thing? Ah, yeah, that's fine. It's not great, but it'll work. I just slide this there. Oh, I just had a devious idea. Oh, we're totally doing this. Oh, this is going to be hilarious. You guys are going to love and or hate this. All right. Let's put this back. One moment. I'm going to rearrange the camera. Thin line between love and hate, to be fair. Yeah. Yeah, this is going to straddle that line pretty tight. All right, putting that through there first. Then I think this will work. All right, the connectors are through. Rough up the transformer, get past that cable, and we're golden. Make sure the lines on all the standoffs. Slides back. Beautiful. Okay. Let's plug in all the cables. I didn't notice this. It's labeled Agilent on the cable, just in case you forgot. That was anticlimactic? Oh, we're not there yet. All right. Oh, I should remove the mounting poster tack. That would be smart. There we go. Just set that aside for now. All right. Now we need to reattach this. And you know where I need screws? Well, I put the screws in the plastic storage bin, but you know what? There's a handy dandy second set of screws right here that I need to remove anyway. So I might as well just do this. Yep, that one. Oh man, it's weird when the floor's clean. You can just see what screws you dropped. Okay, maybe this wasn't as controversial as I thought it would be, because this was it, moving the screws from one board to the next. Where's the other screw? I know there's two. Oh, it's way up there. Unless I lost internet. Here's a floor. Ah! Okay, this one really sucks to get to. There we go. The floor isn't lava yet. Why do they look different? Because they are. Thought it was 4 identical ones. No, it is these 2 are the same and these 2 are the same, which is really annoying. So it's 4 output. It's 2 ranges. So one is 0 to 20 and the other is 0 to 50 volt, but with 0 to 2 amps and then 0 to 0.8 amps. So they're 2 different ranges. So there's 2 pairs of board types in here. And again, they're opposite corners. It's really weird. So those 2 are matched and then those 2 are matched. Culminated, the answer is yes. It is very well tap endowed. Very, very well tap endowed. I just realized this is in the way. We'll see how this goes. But, oh, you know what helps if I unplugged all the things. This one isn't as close to the wall as that one was, so this may not be as bad. We'll find out, though. And then there's the front panel cable. Yeah, this is going to suck. This is, you know what? I'm just removing the front panel cable. Let me take a picture of that. You want to hear the fan running? It is quite the finger chopper AC powered fan. Fun fact, the fan on the SIGGEN was unplugged when it got here. I don't know why. I don't like that. Also, it has the 10 megahertz oven option, but someone removed it. I was really disappointed by that. Weirdly, it still says option 1 on boot up. So it's in the ROM or something, not like a detection. It doesn't query whatever bus to find out what's installed. Oven option, if you don't know, don't worry, because it's not that important. Spectrum Analyzer has one anyway, so if I really care, I can just bridge off of that one. Oh, this is... this sucks. This is bad. Man. I'd almost be better trying to desolder the back and then the rear panel connector and then trying to just remove it straight up. Jeez. I might have to. I have regrets. I shouldn't have done that. Thought it would come out that way. It will not. Or will it? Maybe I was right. I was right. I may regret nothing. Haha, I'm a genius. Okay. If you use a SIGGEN with Spectrum Analyzer, you almost always want to lock the 10 megahertz to each other anyway. Yeah. I don't need to do that because it turns out the Spectrum Analyzer is a network analyzer and it has a tracking output. So if I'm using the SIGGEN, it's probably for fun and I don't really care. One moment. No what? I don't, what is the no RF programmer? Network analyzers have phase information. So the manual does say it can do network analysis. Maybe their definition of that in 1979 was different. I don't know. Have phase information. So what that would be 2-channel then, you're saying? So it, at the very least, because it does, I don't know. I don't know. I'll have to look up. Yeah, so it'd be non-vector. Yeah, there are I did look that up on Wikipedia. There are 2 types. It would be a non-vector one for sure. I don't know if that precludes it from being considered one at all. Oh yeah, I want to clean it.
Magic contact subbed as tier 1 and says, how dare you mess with people's schedules. End of line.
Majeko, thank you for the tier 1 sub and for 32 months. I appreciate that. All right. Stating the thing I always say, this is an ESD safe vacuum cleaner. The tip of this is electrically connected to ground through a 1 or 10 mega ohm resistor. I don't remember exactly what, but it cannot develop a static charge and as such is safe to use on electronics. It is made specifically for this purpose. So don't freak out that I'm using a vacuum cleaner on this and don't think you can just use any vacuum cleaner. One of these days I'm going to have to actually clean the filter. I'm not looking forward to it because it's sealed and they really don't want you to. Network analyzer requires a coupler and yes, it needs 2 receivers. Is that the difference between vector and non-vector though? Because I thought it was like SNA or something is what this one's considered to be. I am curious to look it up, not to be like I'm right or whatever, but I would just like to know. Network analyzer. Hold on, I'm sucking at using a computer here. Okay. So I just want to look up what I saw that was the information that I had. So it was, yeah, scalar network analyzer, measures amplitude properties only, vector network analyzer, phase and amplitude. So it's an SNA network analyzer, isn't it? Because it is amplitude only. But it's no longer done since you, but it is no longer since you cannot calibrate them properly. Okay, so you're saying because mine's out of calibration, I mean, everything I use here is out of calibration. I'm not gonna spend like $1,000 for someone to come and calibrate my stuff that I use for making videos on the internet. If I was doing actual work, it would be worth it, but I also wouldn't use this. I mean, maybe, I don't know, like 34401A is pretty good, but not that spectrum analyzer, that's for sure. But that was what my interpretation was at. Basically, high bandwidth audio equalizer display. Yeah. Well, no, well, that's different from the calibration for VNA is actually in alignment. All right. Well, but for the SNA, I don't know. It doesn't really matter. I don't really care that much. I do need calibration standards. Every time I've looked for them, they're not inexpensive. So, unless I've just been looking in the wrong places, I don't see that happening. All right, I'm just gonna blow this out. We did the vacuuming. Oh, that's the wrong table. Look, it's I knocked over the 3-in-1 oil, my manifold for the air compressor. Let me just do this. Okay. Even with the vacuum, there's still so much I can't get. Maybe with brushes. Too bad there's no one here who would recommend I use brushes. Yeah, it made a huge difference. So before you're dealing with that bandwidth, you don't need an expensive calibration set. DIY easily. Interesting. Literally popped back in just in time to hear that. See, yeah, ouch, $150. And that's just for the spectrum analyzer. Like, that doesn't get me. I mean, like, well, I mean, yeah, that's what it would be for that. That's 3 times what I paid for the tool. I missed today's stream because of work. Good luck with the repair. All right, no problem, Digital Ice Age. We're not doing super critical stuff, so don't worry. Okay. That's looking a lot better. All right. It's one spot for one more cap for extra performance. Oh, yeah, right there. Yeah, all of them are missing it. And by all of them, I mean those 2 boards that are the same. All right. Let's start yoinking reefas. Pay like €45 when they were way too many in the market. I wouldn't be against it, but I would need like so much stuff, especially for the DMM. I do want to have a day, maybe, I did blow the heatsink out, Old Master. Maybe Sunday, we do... Whoa. Sunday, dump the calibration info from all of my tools. The refrigerator's coming tomorrow. I was trying to figure out how I want a water line from the sink through the cabinets behind the oven. Cabinet is just the first time I ever moved the fridge. Came with the house. It's already a water hookup back there. Ah, nice. Don't need rubidium source. Absolutely money waste for you. Yeah, so fancy things like that I don't want. But like a standard resistor reference or DC reference, something like that. I don't know. Anyway, look at the warped PCB from the mount point for the heatsink. That's insane. I've never seen that before. At least not that small of a warp. Like, it is noticeably concave right there. The other one is like that too. The other board did have the same warp. Wow, I did not notice it that time. That is nuts. And Danberg, so this is about calibration. It's a different kind of accessory. So, and it's applicable to basically every test equipment manufacturer. So it's really not HP's fault. Looks like I swapped this over already, so it should be ready to go. Let me grab the solder. All right. It's this one. Oh, that one wants to fall out. Come on. Do it. You know you want to. Ah, just so close. I think one of the legs is bent. Talking about calibrating frequency, not calibrating short open through. What I was referencing is I would need to calibrate like the DSO inputs on my 16500C, the power supply outputs on the 6633 and 32, the voltage DC, voltage AC for the 34478 or 3478A and the 34401A, the resistance measurements on the DMMs, the frequency counter on the 34401A, the output frequency of the 3325B, the output frequency of the modulation source on the 3325B, the frequency calibration whatever thing for the super heterodyne tuner in the 3585A spectrum analyzer. Like, it's a lot of stuff that I would have to have calibrated. So like, it wouldn't be just one thing that I would be buying. I would be buying like 9 different calibration tools. So that's what I'm saying. Like, I'm not probably ever going to buy the stuff or make the stuff to calibrate my own equipment because I don't see it happening. Like, maybe resistors for the exact same reason that our programmer was saying I should put 2 100s in series, because like I could just buy a billion resistors, put them all in series, and then have a good enough calibration source for resistance. But voltage, frequency, like that's a nightmare. And if I'm picking like individual things to calibrate, it's definitely not going to be the spectrum analyzer first. That's probably going to be my least used tool I own, aside from the HP analog sweep oscillator, which I bought because it's pretty. So that's way too much. So you meant, yeah, SNA measurements? Nah. Yeah, I'm just saying I would need so much. If I was going to do everything I've got. There's one. So that is 165 for, is that frequency, power management IC, evaluation board? I'm not sure what that is. Oh, oven-controlled Zener precision voltage reference. Okay, so that would be for voltage calibration. Yeah. So Cobb's comment about bulk discount. It could make sense to pay a professional calibration service to come calibrate everything all at once. But I don't need that. So, oh, I just realized why the boards are in the opposite corners. This is mirrored. Because I was thinking, wait, this cap was on this side last time. Yeah, it's because it's one board type for the 2 outputs and they're mirrored. Yeah, that's okay. What happens if you have them all configured to be the same? Every part is through hole on here, so they could assemble it backwards. Huh. I wonder if Curious Mark has necessary. Yeah, I bet Curious Mark has all the cal stuff. It's just Curious Mark has like everything HP's ever made. Come on. There we go. Okay. Now.
Peter will be subbed as Tier 1 and says hello HW guy and HW guy here. End of line.
Peter Wolf, thank you for the Tier 1 sub and for 2 months there. Let's see. You do not want to pay for calibration. You want to do alignment. If you send anything out to Cal Lab, they will tell you it's just out of Cal. Oh, okay. So they won't actually do calibration. That sucks. Hallencroft, no. What I'm saying is that there are two different types of PCBs here, and they're mirrored. Like, this couldn't mount here if I wanted it. Well, yeah, that could not mount there if I wanted it to, because it actually goes this way. So it could mount here, but it can't mount here. But maybe if you assembled it upside down so that this was the top, then it could mount here, because I believe you could get this with all four outputs being the same. So that's the thing that was tripping me up there. All right, anyway, that's the tiny blue one, 2.2 nanofarad. I need to grab that out of the storage bin because I'm well organized now. Anyway, the calibration stuff really doesn't matter because we're not doing critical measurements. At least not for 3 weeks. Be weird if the ICs also worked upside down. Okay, yeah, that one wouldn't work. You're correct there. Do they make inverse mounting sockets? Dude, what is going on with this thing? Need like a needle point iron tip. Clear this out. There we go. Oh yeah, that's not on. This is one of those stupid things I really want to buy that like I absolutely do not need to buy. Like super don't need to buy. I want it though. Metcal makes a remote mount handpiece switch. I want one. Because then I could just mount it like at the front of the workbench and not have to reach all the way back to the base station. It's meant also to allow you to connect multiple instruments or multiple handpieces to a single output if you don't have the MX500 base station that has two. It also does power measurement, I believe. With that part's really cool. And I might be mixing things up. There might be power measurement and a switch, but I would really like that because it sucks having to reach all the way back there. Buy it, treat myself. Probably spent $300 on HP garbage this last like 2 weeks. I think I'm done for a while. Do you have a Throne account? I don't even know what that is. Buy Metcal, you lease Metcal. I buy Metcal. All right, I think I need 2 of the 22s and 1 of the 15s, right? Yeah. Look it up, website for users to provide wish lists. No, I just have an Amazon wish list. The only thing on there currently is something I genuinely actually need. It's Silverstone, like 600 watt power supplies for random computer stuff, but that's it. Go buy Aqua Team for PS2. Definitely there's better things that I could spend $50 on. Absolutely. Say garbage, you're going to have at least $300 worth of fun with them. That's true. Although I bought the manual for the Spectrum Analyzer, Volume 1 at least, as well as Volume 1 for the SIGGEN. I've read those now, but I do want them for reference material, especially when I was looking through the Spectrum Analyzer manual, and like midway through it, it has example workflows for how to do specific kinds of measurements, like the full test setup, like just straight up documented right there. That sounds incredible to have as reference material. So I wanted that. It also comes in a 3-ring binder. So I might get that. And then like the manila tab things. I can just put like, here's how you do a spectrum measurement, and then I'll just flip open to that so that I can just like read and punch the keys in. Because I remember how it all works right now, but that's not going to be true in a month. So, all right, let's look at this. The two ref deses are aligned the same way on here. So HP are just animals when they assembled these with them on directions. Actually, Agilent. Agilent was the one who put this together, not HP. Don't blame poor HP for Agilent's mistakes. We all know by this time HP was charging for, you know, drivers or whatever, for printers, or, you know, they're evil by this point. All right, man, it'd be so much easier. I could just put them on this side. Very glad to have manual for logic analyzer, especially with the state options being vaguely baffling about the docks. Yeah, so I've kind of given up on getting manuals for the 16500C because I need like a shelf space that big just for it. I'm already not 100% sure where I'm putting all of this stuff. I would kind of like to maybe get a shelf that is accessible here, maybe goes up and over the test gear to be able to reach all that. Maybe it goes over the whiteboard or something. I'm not sure, but I would like it in this room, not the other room, so that while I'm using the hardware, I can just go over, grab it, and get the reference material. Specifically for GPIB programming, I want that. So I think that would be extremely helpful. I'm going to put this here first, and then this can just get pressed down beside it and pull it near itself as it goes in. That should mount very securely. The same here. Ooh, I'm pinching it under there. That's not going to be good. Okay, we won't do it that way on those. Okay. So you need vintage HP branded 42U rack. I don't want the stuff rack mounted. I want it bench mounted. A rack doesn't fit into how I have this set up. There is no way I can use a rack for this stuff. In order to use a rack, I would have to give up this corner. Name brand frame grabber for 820 Chinese clone, just reprogram the EEPROM. Not sure what you mean. Very good. How much weight do you think a French cleat shelf could hold? I want to say it's a shoe thing. I don't know, man. I own one pair of shoes at a time. To PCI ID reprogram. No, it's not a shoe thing. Okay, well, I don't know. It's a wall mounting system. No clue. I have a single pair of shoes. I mean, I own sandals. Those don't really count. Those are like, mail was delivered. I'm already home. I'm not going to go like put on socks and shoes. So yeah, like one real pair of shoes. Yes. Oh, that sucks, Philip. Hopefully it wasn't a like cool vintage one. I have been after the like 40s green glass brass overhang, like long fluorescent fixture kind of light to go over a Selectric for so long. So yeah, if it was something like that, I will shed tears on your behalf. Really cool vintage one. Oh, that is unfortunate. 60s. That really sucks. See, what if you have to go somewhere in a suit with dress code? That doesn't happen. At least not for me. No weddings. I have never been to a wedding that had a dress code like that. That kind of sounds like the kind of wedding that would be a pill to go to anyway. Like maybe if I was the best man or something, it would make sense, but... Love such a stable climate. One pair of shoes is enough. I feel like that's kind of the opposite, but... Oh, stable climate. You mean Arizona. I thought you meant like life is easy. Like you meant like weather. Yeah, no, I don't have like snow boots. No. Tuxedo plus Nikes. New Balance, but yeah. If Nike shoes weren't made... Ooh, if Nike shoes came in wide sizes, maybe. But I have to wear New Balance for my flippers. Okay, this is going to go back in so much easier than it came out. That was a cakewalk comparatively. Literally weather, yes, yeah. Okay. Yeah, the weather here, pretty predictable. Also, pretty terrible this year. We're gonna die. It's gonna be so bad. You ready for it to be 140 here, Desiac? I don't think I am. What is this stuck on? Oh gosh, the stupid cable. Okay, hold on. Oh no, you're not. Yeah. Our live routinely goes from scorching hot in summer to substantially below freezing in winter. Oh, I mean, it does that here too. I just, put up with it. Let's see. It is currently... that's not right. It's 70 right now. The high will probably be around 80 in February, the first week of February. So yeah, this year, be prepared to see some insane numbers coming out of Arizona. 67 in Queen Creek, yeah, those are, and that's better, but them some high numbers for February. So what the problem is there's a current sense wire that is jammed underneath that panel connector, and I got to get it out because it is catching and preventing the unit or the board from going in. There we go. This. Are you silly Northern Hemisphere people are backwards? AC in the black car is strong in his mind, and mine alone not to ride the bike in the summer. Ah. Why flathead screws, man? There we go. All right, we are halfway done. This is taking forever. Minus 25C in February, plus 35C in July. So yeah, that sounds about right for here. There we go. In. Okay. Do the same thing as last time. I need screws. There are screws here. Just transplant them from one board to the next. And these ones are so much easier to remove. I do not know how I'm going to hold this in. I'm going to hold the screw with the tweezers and then screw it in from the top. Because this sucks. I would try and get an angle, but I can barely see it myself, so I'm not going to be able to point the camera at it for you. Sorry. There we go. Okay. What do you mean right here, you don't get below freezing in Central? Oh, no, we definitely do. Not that often, but it doesn't snow because it doesn't rain. We went, I think, 160 plus days without rain before I did the video on the GPIB stuff. Yeah. And just to be clear, that's rain or snow for you people who get snow. So even if it freezes, nothing's going to happen. It's just going to be cold. One day short all-time record? Yeah. You couldn't be doing with that. I don't like it. It sucks when it doesn't rain. And it's not just like, oh, we need the water or whatever. It's just, I like rain. I want to go stand in the rain. And I was like really actually busy trying to get work done. I couldn't stand out there for long. And they say it never rains in Arizona. Yeah. We got our once per year allotted allowment of rain. Yep. Whoa, that one is a messed up connector. Okay, I might want to really like test this power supply once we get it like, you know, up and running. That's why you daily drive on drag slicks. Yeah. Okay, I think that's it. It's just the 3 cables. Yeah, and that is secure. And then this is insecure, so I can just yoink. Oh, I got more cable management to cut. Oh yeah, 95F, that's nothing. Absolutely nothing. We like it when it's only in the 90s here. I'm not kidding when I say this. At some point on stream, okay, I will be able to go outside during the summer with the thermal camera and take a photo where I read like 150, 160 on a surface out there. And the actual air temp in that area will probably be in the 140s if I could measure that easily. But that's just because of the suburban heat island of it being all concrete and stuff. But the air temps will get insanely high. They will get into the 120s for Fahrenheit. I'm gonna unplug both of these at once because that'll allow me to move the whole thing out of the way. Yeah. Oh, I should plug the front panel back in. That would be smart. Oh, which one did it go into? Oh, the only ones that it could plug into. That's which ones. What's that bonus connector for? Is that for RS-232 or another HPIB? What is that one? By the way, that board's HP branded. Doesn't say Agilent. You guys missed one. Ha ha. Can't measure the air with IR. No, you can't do that with IR. I'd have to use like some, you know, like mercury-based thingamajig. But, I mean, I do actually have a mercury thermometer in the office. I have a super cool vintage one. Oh my gosh, it's awesome. If I had windows that opened, I would use it. It has a remote thermostat on a wire. It's crazy. So you can have indoor and outdoor air temps. It is very vintage. It's super cool. The reason you glow in the dark. All right, I gotta show you. It's too cool. I talked about it too much. It's awesome. If I could use it, oh my gosh. Besides, we haven't had that many distractions yet today, have we? We got time. All right, where did I put it? Should be right around here. Monitors are heavy. That's not a thermometer. Right over here. Where is it? Ow. PCBs are pokey. Where did I move it to? Dummy. Okay, I'm not sure where I put it. Now I'm sad. Go and talk it up, and then I can't even show it. I'm bad at this. I see my frequency counter that uses Nixie tubes, though. There's zero chance I'm getting it out for the stream. I can't. It's not possible. Oh, I need to not have that on there. Okay. The HP breadboard I was sent that had, the HP breadboard that has a like funky programmable logic thing going on it or something like that. The feet are decomposing, and it is sticking to the thing that it was sitting on top of. So that was good. I found that at least. I have no idea where the thermometer went though. I got one other area I can check, but now I'm sad. Lost the awesome thermometer. Oh well, yeah, I don't know where I put it. I probably put it in a box because I know I'm never going to use it. So, oh well. Well, that was a waste of time. Yeah, I give up. Okay. Anyway, just imagine like a 60s like fake veneer aluminum extruded chassis, 2 mercury tubes, and then a wire that goes off for the second tube that you're meant to put outside. So, supposed to be streaming in a couple of minutes. Maybe wrap this up, get ready to start. Yeah. All right. 3 out of 4 here. Okay. Whew. For those of you who may be joining us after the start of stream, I'll just reiterate what we're doing. I have here an HP 6624A power supply. It says Agilent on it, just pretend it says HP. The power supply has 4 output boards like this in them, and each one of these output boards has 4 refa capacitors on them that could blow up if I tried to power it. So we're replacing all 16 of them in total in the unit. So that's all we're doing today. Well, at least for right now. If we get this done early, which we're probably gonna have some time, we're gonna play around with signal generator and spectrum analyzer. Whoa. Yeah, everything that's on here, I can't get off with a vacuum. I don't know if horsehair brushes are safe to use on electronics. I'm pretty sure not. I would have to use one of the ESD brushes with a vacuum, and I've honestly not found those to be that effective. All right. Yep, and it's got the warped board damage as well. All right. Wow, that is super dusty on the bottom side. Okay. Several colonies of dust bunnies, yeah. All right. Solder. Good for agitating dirt and texture surfaces in your HP workstation. Yeah, that, I mean, that would work better than on a PCB directly. I do agree, they'll have use cases. I just don't think a PCB is one of them for the safety of the board. Hope that dust isn't structural like a HP workstation. Oh my gosh, Majenko, I think you sent your message as I was reading DZX, and I didn't notice the line shifted. So DZX said they are good for agitating dirt and textured surfaces with the simple green. That makes sense. Then Majenko said, I hope the dust isn't structural like it is in your HP workstation. Yeah. My brain, I missed that entirely. Makes sense where ESD protection. I shouldn't be, really? I mean, I can. I do have it right here. I suppose I can. I mean, maybe I should be wearing it right now. I mean, I should be wearing it right now, but, you know, just, nerds. Fine. There. And to confirm correct usage, I'm not putting it on the hairy arm side. It is on the loose or the bare skin side, because if you're gonna wear it, you want it to actually do something. Dude, why is this not heating up? There we go. See, just wear the wireless one, yeah. Okay. That was not a good application or extraction. Let's use that term instead. That was better. Air compressors, that will run a whole lot more this time than usual. I wonder if it's trying to keep the tank topped off more than it really needs to. Or maybe I'm just working it hard, because I don't normally remove this many things at once. Looks confused. Hole strap is conductive. Orientation doesn't matter. So Majenko, it's hole strap is not conductive. This is just nylon. At least I think it is. Maybe that is conductive. You know, I never get checked. I just assumed that this was just like garbage elastic. I assumed that you had to touch this to bare skin. And if I put that on this side where there's arm hairs, it would be less effective. Should be wires in it. I mean, it's an actual iFixit brand one, so let's find out. Setting the meter to 2-wire resistance mode. Oh, someone's got a weird probe on here. Hold on a second. I got to swap that. There's the normal one. I think I need to come up with a better probe storage solution. And by better, I mean any. Because I think the bins are a terrible idea. Okay, so I'm just going to stick these on the band. What do you know? Okay, that's conductive. I did not realize that. So that is 9.8 kilo ohms there. Well, that's cool. The exchange rate, shipping wasn't so terrible. You may be getting another HP Analyzer 16500A. Is one available in my area. Jake's been pressuring me into getting it. No, don't do that. There's someone who is already looking at sending me an A. So I appreciate that, but that's probably already going to happen. Janky conductive elastic then? Yeah, I guess. But yeah, okay, that's cool. I did not realize that. So it kind of doesn't matter how you put it on. Okay, good. See Machenko, you don't have to. Yeah. I appreciate the thought, though. Yeah, that's actually the main reason I was considering getting the B, because then I would have A, B, and C, but I really don't. I mean, I don't know. Especially with the other HP stuff, yeah. All right. One more of the big ones. It'd be good for a doorstop. I don't think my heart would allow me to do that. I think I need to reflow these. There we go. Okay. And yep, caps on that side because they're mirrored. So can I do it? No lead solder. The answer is no, but you know, just for giggles. Oh my gosh, this solder is so terrible that they use. It's probably early Rojas. But you know, enough. Ooh, that gets warm on the thing that's connected to the thing I'm soldering. Rojas is another one of those weird things where the pronunciation is probably going to vary dependent on region and experience and all that fun stuff. Funny thing, I actually have no idea what the acronym for Rojas is. Never even considered that. Blues Fire, I don't think that's an or. I think it's an and. I think that's the problem. My solder is 6644. So we can't say Clo. Am I mispronouncing that? If I have been, let me know. Okay, so would it be Chloe? Because not Chloe, I assume. Is it A, Chloe, or B, Chloe? Because I would assume it's B. Philip, you may as well say it's GIF versus GIF. Long E, Chloe. Well, so I get the Chloe part, or the E part, all right? It is Clo, not chlo. Just to be clear, because when you like put the like pronunciation out, I would not expect the ch there. Yeah. Hard ch, not so. Yeah, but when you're doing like phonetically, you would change that out. But okay, Chloe raccoon. I think the other part may have been that it flows better because Chloe raccoon is going to add another syllable, but I will try to remember that. I will try. Reach pronouncing correction. What is people's names? I care. When it's nebulous industry terms, nah, whatever. Oh, that's right. It is Moog. Yeah, I said Moog, didn't I? Yeah. Did better in DVLA here.
Ultimate says, I hope the deck talk is paying attention to close complaint. CHEER 100. End of line.
I mean, actually, it would be a kind of cool deck talk redeem is a custom substitute. Like you could have your name have a phonetic substitute, like built in. Wow, this was terrible. I may have roasted those pads a little. I don't know. I don't like how that just went. One moment. I'm removing that solder. Rename yourself as a GPIP programmer. Minor pronouncing the name of Michigan's largest city. Stress the second syllable. I don't know what Michigan's largest city is. Or second largest is. So I think I'm good. I claim that on my TTS, but I said it. Not the user means many of users have nicknames for face. Yeah, see, I would make it a point redeem, like maybe 50,000 points or something, where you could have a word be substituted, but it would be for all bit redeems, so it would affect everyone. And of course, I wouldn't let you do things like the. So you wouldn't be able to substitute that. There would be limits on it, but I think it could be cool. Yeah, can you change someone else's name? See, now you're getting into some questionable subjects there. Gosh, the back and forth. Stream changes to 18 plus. I mean, again, I would have to manually add it, so there would be instant feedback on whether or not it's happening. It would not be automated, that's for sure. Detroit? There is no way on earth you're going to convince people to pronounce it as Detroit instead of Detroit. Good luck, Silent Searchlight. I'm sorry, but no, I refuse. Nuh-uh. I am not taking that bait. I, an outsider to there, am not going to try and fight for some kind of niche correct pronunciation. I'm going to go with the the nationwide accepted normal way. That's not my fight. If I lived there, sure, maybe. But not when I live in Arizona. I feel that's not bait, more like a detonator. Yeah. Detroit is perfectly acceptable. Just don't call it Detroit. Detroit. Over pronouncing the first part of it. Okay, got it. Ah, Cool Blues Fire. It is it's the best place. Except for the housing market. Environmentally, it's great. How about that? How about that part? Environmentally, it's fantastic. Fox sneeze. Philip, I feel like you're asking dangerous questions there. You're not really taking me like 20 minutes each. Oh, gosh. All right. Group Phoenix in the F section. Yeah, I mean, at least that's slightly English, but I will never remember. Essentially, you misspelled it in one of the ways that I will misspell it. It's, I think, Phoenix. But whether it's OE or EO, I don't know. Oh, you know what the best part about Ahwatukee is, Dziak? It doesn't exist. I don't, is it actually a real city? I think it's just an area name, isn't it? Yeah, it's not a city. That's the best part. Is that you're native to the area and still can't spell it? Actually, hold on. Oh wait, no, you were correct. I missed the silent H. I was close. I was close. Well, that's Phoenix. Yeah, different. Phoenix is easy, but that's because one of my clients' business name is Phoenix. So after 15 years, you can spell it. Yeah, I mean, I have some number of years greater than that living here. I can't spell it correctly. Ever been to? Nope. I don't know where that is. I have the only other country I've been to was Canada, and if this is the American border to Canada, I basically just put one foot barely over into Vancouver and quickly came back. Tucson is one I always have to think about spelling. Nah, you just got to remember. Tucson. Done. You'll remember how to spell it for the rest of your life. Done. That one's easy. Yeah. Dziak, that's Canada. Vancouver is what I was saying. When we visit a German metal festival, I mean, that does kind of sound like up my alley, except for the I gotta leave. Like, my couch. I'm not a big travel person. Have I ever been to New York? Okay, technically, yes. Or wait. No. Maybe? I am not sure. I know I've been to Chicago. Because I went to the pizza place. Let's see. Just a string of consonants is not really that pronounceable, Silent Searchlight. All right, we're on to the final one. We're almost done. Oh yeah, I should take off the poster tag. Can you get pineapple pizza at the pizza place? I don't know, but you shouldn't. Let me put it this way, at the pizza place, I just don't remember what the name is. It's, you know, whatever the biggest, fanciest, like, tourist pizza franchise is, it's that. Anyway, bread, cheese, sauce. So, I don't know where you'd put pineapple in there. I'm not even sure where or if they put pepperoni in there, honestly. It may not have even had it, I don't remember. But that's a pizza after my own heart, because it was very heavy on the sauce. Why a sauce above the cheese? That's a valid question that I do not have the answer to. The only thing I can say is that I very much appreciated it when I had it. Bread cheese sauce is just wrong. It seemed wrong at first, but no, pineapple on pizza is disgusting. You don't want sweet things on pizza. That's just wrong. I don't want chocolate chips on my pizza. That's ugh. That's what I'm thinking. Nah, I thought it was like, I want to say Geno's or something. I don't remember what it is. Sold chocolate pizza here for a while. The for a while part tells me all I need to know. I think I'm good, Desiac. All right. The last one. Is this really still heating up? Jeez. Won't fight you over pineapple pizza unless you eat the more you can have. I mean, that is a enlightened way of looking at it. Oh, the triggerfish. I mean, yeah, those are super cool. The Huma Huma is the one, isn't it? White with the blue and yellow and black accents, I believe. There's a couple of different ones. The clown trigger, I believe, is a polka dot one. That's mostly brown with white spots. Yeah. Ah, man, this is the only board that... Oh, never mind. I'm going to complain about nothing. Don't mind me. Just being wrong. Actually, I'm not wrong because I didn't say it out loud. Oh, my gosh. Oh, clean the dust off. Don't solder through the dust. Oh, that was awful. Anyway, Meltdown, you just made me realize it's time for me to rewatch Futurama. because I cannot remember the name of Zoidberg's home planet or what his species calls themselves. Because, you know, all the anchovies are gone. Aquarium Arts has one big clown trigger in there for the better part of 10 years. No one will buy. I think their big display reef tank is gone, so it may be gone too. Ooh, yeah, it was pretty great. I do really like their giant freshwater one they added a couple of years ago, though. That one's pretty jamming too. I mean, it's nothing like Ocean Floor. Dude, Ocean Floor right now has 2 catfish, one of them red tail. It's man, if I could have one stupid fish, it would be that. They're awesome. That stupid $20,000 acrylic tank no one would buy. If you buy that, they should give you the red tail with it, because that's what you need. You should pay you to take it at this point. There we go. And all reefas removed. Whew. Just trying to say I enjoyed your last YouTube video. Well, thank you, Shazner. I appreciate that. We're kind of just doing that more today. This is about a GPIB programmable power supply here. I won't be making a video out of this because we're mostly just replacing a just absolutely stupid number of reefa caps. These are all from this power supply. There were 16 of them in it. We're just trying to make it like safe to use. So that's the primary goal for today. But then we're going to play around a signal generator and spectrum analyzer, which I am extremely looking forward to. All right, 2 more 22 nanofarad caps. Any of them looking iffy? No, all of them actually look really good. Some of them look completely flawless. Like, weirdly so. Although now I can't find the flawless looking one. Is that it? No, that one's all cracked. Cracks. Some minor cracks. Where was the like, scary, perfect one? Anyway, there was one that had, like, literally 0 cracks. It might be this. It's got a bunch of them on the back. But anyway, they didn't look bad. But they did look like I said reefa on them, which is bad. But the flawless one's back in? I don't think so. They're not reefa, but yeah. Made a video about replacing all the caps with Power Splash. Reefa Madness, yeah. I'm sure that that would not be the first video named that. Even in just the context of vintage computing.
David Phantom subbed as Tier 1 and says hello. I was driving a lot for work. What did I miss? End of line.
Do you see what I'm doing right now? Imagine that 10 more, 12 more times. That's what you miss. So not a lot. But David, thank you for the Tier 1 sub and for 35 months. I appreciate that. 75% more of this, yeah. Well, more like 175. No, wait, brain, 300% more of this. We need to do solder them in on a long PCB, hook up power, and see if they go off like a string of firecrackers. I don't think so. No, I don't think I need to do that, actually. Another one, so it's a 4-channel power supply here, David, and these are the 4 output boards, and they each have 4 refa capacitors on them. So I'm removing 16 total caps.
CHER 100 and a line.
David, thank you for the 100 bits. All right. Let's pump these in there. There we go. Guess I could re-angle this. All right. Four by 4 refa, yeah. I have never detonated a refa, so I wouldn't know how it smells either, other than I never want to learn what it smells like. That wouldn't be the best thing to do in an office, because the ventilation is shared. Is that putty heat resistant or just is gum? It's just poster tack. I'm not putting it on the pins. I'm just putting it on the body of the part. That way it holds it in place. It's nothing special. Just go to your like local office supply store and get poster tack. It's just that. We collect 100 desoldered ones. Oh my gosh, that would be so much. So I've with like very badly burnt resistors and electrolytic capacitors. Huh. Could be payback for the guy. Oh gosh. Yeah. Yeah. If I could direct it towards just them, maybe. Done. That's it. No more. We've replaced all of the capacitors. It is finished. Happens when the poster tack heats up? I don't know, because it's not touching the pins, the parts that get hot. It's just touching the body of the capacitor. So it's not really in danger. All right. Oh. Ugh. Forgotten how bad burning reefer smell is until one went off on me in the office the other week. Of course, you had the prolonged zip first and the smell hit you. Ah. Yay. Yeah, I'm going to go ahead and continue to heavily inspect things beforehand to avoid that. Although I will admit, I forgot to look at the signal generator before I powered it for the first time because it was shown being on in the eBay photos. So, and yeah, I got for that one on eBay because I really wanted one. Blue box things are replacements for the reefa caps? Yes. So these are, actually you can see one here. No, here. So these are lined filter safety capacitors. Basically, what these do is they filter out interference from the power lines. So they're not really strictly needed in a lot of use cases, but on this thing, they're like past the main transformer and they're onto the separate subboard. So I figured before I ever attempted anything with it, I would just replace them to be sure. Dude, camera focus. There we go. So yeah, just because of how many there are. So. Cobb, I'm pretty sure, yes. That is RJ11 because it is for the communication protocol that allows you to program the boards independently. So these are 4 independent power output boards, essentially, and they have a GPIB interface right here that controls all 4 channels at once, and that is the communication connector for the programmable interface. Clean floor means found screw. It's kind of enough of a reason to clean the floor by itself. I've never seen banks of Rifa capacitors. I don't know why you would have that. Maybe if you had like really noisy stuff, but usually it's just for the power supply, which will run at 1 frequency. So you wouldn't have a reason to have tons and tons of them. Oh, there's no this on the, I presume, low output boards. Weird. I didn't notice that until just now. Huh. Why is this so tight? Oh, at least it won't matter in a moment. All right, you guys ready to turn this thing on? Because we're at that point. Does the yellow thing be back left of the board? These? I think that is another line filter cap. It says M2 though. I don't know. It says 1 UF and then K100. I don't know. All right. I'm going to slide this closed. This just always feels wrong. Let me check all the connectors first. No, off by 1 pin connector. Errors. Nope. Okay, we should be all good. All right. Now this power cable is plugged into a power strip down there, but I'm going to plug it into the workbench that has a breaker. I have 230, 110 selector switch. I'll check first. It would be weird if it was set to 200 for many reasons, but just for giggles. And I know I was going to put it on the rheostat, but I meant Variac, but nah. Okay. There's like a solid black fuse here. I don't know. It looks like it doesn't have a switch. It just auto detects or something. So I think it's fine. All right. Blue caps are huge. Oh, no, they're nothing. This isn't even the biggest sprog in the office. There are caps bigger than this in the data generals. So if you ever wonder, why is Shelby not working on the data generals? Variac, I decided against it. I'm just gonna YOLO. All right. Plugging in power. Wishing this had a less dumb LCD. All right. Here we go. Much fan, such noise. Wow, that's loud, but hey. There's a lot of airflow. Oh, it's positive pressure. Actually, that makes sense. All of the HP stuff is positive pressure. There's supposed to be a filter on the back then, isn't there? Why isn't there a filter? We might try and lubricate the fan here. Everything else seems pretty good, though. Static on the video. It can't be static on the video feed. It's HDMI. Needs more sponsor content from our favorite fan manufacturer? I don't know. This is this is a lot of thing to try and replace with that. All right. It really does sound like it could use some bearing love. I want to remove the fan and take a look at it. It's still slowing down. It may not be bearings. I have a feeling that there were no Macs that were sold as loud as this. I don't think it comes across well on camera. This was very loud. Yeah, this isn't just a, you know, little 120 mil replaced with a 12 volt fan. This is an AC mains power fan here. I'm still going to try and lubricate it, but wow, that is really, really smooth. Maybe we just install the Variac for the fan. How many amps? Well, we'll see in a moment once I get it off, because we're going to take a picture of the label. So I have that documented before I tear it. Because you got to put oil in behind the label. Ah, good. It's on a plug. Time for noise suppression circuit? I don't think so. Although I'm tempted to put a filter. Like actual just dust filter. Because this could easily pull through that. Special cordless fan. Okay, so this is 15 watt AC fan. So I don't know how many amps that is because I don't want to do math. All right. Just rule of thumb, you're going to cut the label. Just take a picture of it first. There we go. Is there a bearing? What? It's just plastic, and then there's whatever this silver thing is. There's some kind of hole in the middle. I don't know. It feels so smooth. Well, no, I can hear it. I think more oil wouldn't hurt. But how? What's this center look like? That doesn't spin. Dude, there's nothing there. What? Huh. Well, maybe I just deal with it. Oh well. Yeah, I have no idea. I'm just gonna not damage it. So, Hacky Bus, it's possible there's something up with the HDMI going to this camera for some reason. I've tried to replace all the HDMI cables. I don't know what the deal is, but yeah, every now and then it might just flicker black. Might also flicker gray. That's a different issue. I don't have a fan filter. If I had one, I would put it on there, but I don't. Clip that holds it on is rotating part under that cover. I have no idea how to get it off. It looks like I would destroy it. Moving dust would help him balance. That's a pretty good point, actually. I may have messed with it enough by hand here, but let me just hand wipe all the blades. Yeah, it seems like a good thing to use my hands for. It mounts so smooth, I don't know. I don't think I want to try and pull that off. We'll just leave it. It's loud, but that just, means it's doing good work. That's all. Buy earplugs, yeah. Not a cheap fan to replace. Yeah, not and match the actual airflow capabilities. Yeah, I could try and slap a Noctua in there, and I did do that for the other ones. But this is more power, and this is a much tighter air channel that it has to go through than the other ones. And it's very clearly high force to try and push air through these. So I don't really want to try and mess with it and then kill the output amplifiers on this thing. So, it's just not. Why is it so tight? Hellencroft, I haven't found those. They make gray ones, yeah, but they're not like outrageously high CFM. Like this one's gonna be some pretty robust CFM. Not to knock Noctua, but I don't think they make anything that is like 1/10 as much airflow as this. No speed control always a 100. Oh, it's definitely always a 100. Uh-oh. This one really sucks to put back. Like a lot. So there's a nut that you have to put on the screw, but the board for the for this power supply output is in the way, and it's really, really, really close. And then I can't even have the connector for the fan plugged in. And then how do I hold the nut without obstructing access to the hole? So I'm using the tweezer, trying to hold it on the side. That's not working great. Well, we could probably find 12 volts in here. I mean, there's logic chips and stuff. Oh, I got it on my first try when I held it a different way. Okay, I'll take it. I don't care. Deal. That's the easy. That's the hardest one, actually. Okay. Whew. All right, well, ultimately, that wasn't worth investigating, but at least we know. So. And that's done monkeying with the inside. Let's finish the reassembly. All right, so 2 screws here. It's getting real now. We're going to put the whole thing back together. I don't remember where these all go, so that's fun. You know, I feel like these go on the side, too. No, they can't, because those aren't countersunk. There's going to be 2 more countersunk holes I have to find. I don't know where they are. Maybe on the back? They're on the back. Safe getting a radiator, gosh. The same stream we took them apart. No, that doesn't sound right. We did not take this apart in this stream. This has been sitting torn apart for months. You kidding? I wish. on that subject, cough CM5. Why do you think of this thing's labeled with the thing for the power supply model? Because I didn't want to forget what it all went to. In that case, you retract my confusion? Yeah. This is the wrong size bit for this. Oh, much better. Wow, it's almost like using the right size drivers, you know, smart thing. Okay. Do we get to put the case on now? I think we do. Look at it. It's about to be, oh yeah, the handles. It's about to be all fancy. Let's put it on the correct way. Oh yeah, look. It's pretty now. I got 3 screws that I assume go in the rear. So I should drink some water, so I can tell I need it. Looks brand new. I have not cleaned this one, but it wasn't as bad as some of the other things. Oh, that's good stuff. Okay. Try not to drag the front too much as I move it around, but it is heavy. I think it's actually heavier than the signal generator, although it's not too surprising. This is a little bit more. Dude, where do these 3 screws go? What? I have no idea what is missing screws. They should be at this step. The only screw holes on the outer case are for the step after this with the handles. So before putting that on, somewhere 3 screws need to be installed. What? How? Where? I have literally no idea. Leftovers? Let me check the bottom. God. No. Fan quietening screws, yeah. Are they for the connectors? No. The connectors have their own screws on them and they're flat. Blech.
Chlorocoon says CHEER 100. Check the bottom. Check. Throw back out. Check. End of line.
Chloe, thank you for the 100 bits. Just make 3 holes somewhere. Huh. Wait a minute. Okay. I know where they go, but now I got 2 screws that have to go internally somewhere. And I don't know where those would go. They go 1, 2, 3. I just didn't see that hole before. You know what I call that? 2 extra screws. Do they fit on the rear connectors? No, they do not. Whoops. I don't normally do this, but I'm not feeling particularly like putting these back in, wherever they go. So, let's say bonus screws. There we go. Yeah, I mean, lift up and shake. I don't know if you understand how big the transformer is in this, but nothing. Ah. This is one of those things where you look back and you think, I probably should have worn gloves. This is actually tearing up my hands. All right, now we put the outer case on. Okay. So this part, slightly convoluted. There are 2 kinds of clamps. There's ones that go up front, and then there's ones that go in the back. We're going to install the front ones first. So you loop the handle through there, and you got to put this wedged under the front, and then you can tighten it. I think the vinyl handle needs to go slightly under there. All right. Then we can put the rear on, which also snaps into the back. Why are you not threading? Because I need to lift the chassis. There we go. And then because the holes are slotted, the handle can protrude out for you to carry it. Now we just have to do the other side. One hour 30 it unscrewed all 5 minutes, replace revis, 1 hour 30, put it back again. Yeah, sure. Yeah, we're gonna have less SIGGEN specky time than I would have guessed. We're gonna start with just the SIGGEN and an analog scope. So I'm gonna go grab the Tech 465 because we're gonna do some basic stuff first. And we might mess with hooking it up to the spectrum analyzer. Unless I look and today my Terminators are going to be delivered. Then we'll wait until Sunday. Today or tomorrow. Let me see. Arriving today, the attenuator is arriving today. Supposedly the Terminators are arriving tomorrow, so maybe we'll just stick with the scope. Or we'll get really bored of the scope quickly and then move on. I don't know. We did not test the outputs here, so we should do that. So let me drag this over to the electronics bench. Yeah, front panel, they're missing on this side. No, so these are for mounting rack handles. I don't have rack handles for this. They were removed at some point before I got it. So I am not missing anything there. All right, hold on, I'm just clearing a spot to put this on the electronics bench. Having a clearer spot because I did a whole bunch of reorganizing. Variacs are heavy. Oh, this is empty. You know what that means? Can be freed. Boom. Oh, there's a zip tie in there. So I bought 2 or 3 more of these yesterday at Hobby Lobby, and I didn't notice this. One of them was returned and broken. It had garbage in it, and this is cracked. I would be annoyed, except I'm gonna just glue this and fix it. And then, because this one's already damaged, it's also a bit knocked out of that one. I'm gonna use this one as my experimental one where I disable or chew out some of the walls in between these to be able to fit bigger screws. So even though that one's broken and that's annoying because I paid money for it, I'm actually kind of excited because that gives me the one to experiment with. All right. Gotta figure out where I want to keep, like, lubricants. That's gonna be a new issue. All right. Power cable's already over there, so one moment. Let me move this camera. What is wrapped around here? The foot pedal USB cable. That's not even plugged into anything. There we go. Okay. Oh, man, so many cables in this corner. I am going to want to move the soldering irons before I try and move the camera, or else they're all going to get tangled up real bad. There we go. Okay, now move camera. Oh, this should go too. It is very, like, visually obstructive. Yeah, I'm gonna have to find a proper place for that. And maybe multiple. Okay. In the power cable, something is getting caught. Okay, there we go. It's all good. Maybe. Have to look at that more later. Okay. What's warning? You never want to read in Braille? Wet paint? Yeah. All right. Why did I feel the need to do this? Why am I putting the camera over here? I don't know. Whatever, man. Okay, not sure this is going to work out so great. So, okay, yeah, I can stand over here. That's fine. Yeah. Oh, gosh. So, display on the front, inputs on the back makes this a little awkward to test. So, I'm going to have the probes here, and then I'll go to the 4 outputs, and then I'll program it on the front, and we'll see how this goes. Okay. So it's 1 on the bottom, 2 on the opposite corner, 3 below that, and then 4 over there. So 1, 2, 3, 4, like a bolt pattern. It's weird. Okay. So we should be on channel 1. So we got V plus and V minus kind of there. Okay. So channel 1, V set 5, enter. Okay. 3478 bought. Okay. So that is a voltage measurement. And two volts. Well, that's not right. Is it this? There we go, 5 volts. Oh, they're in a weird spot. Okay, so that output's working. All right. Now let's go to the next output. Oh, the indicator sucks. There's a label on the bottom of the display that says 1, 2, 3, 4, and then there's a little LCD arrow that moves between them. It's gross. Okay. Output 2. Let's make VSET 12. Hold on, I screwed that up. 12. Okay. So 2 will be flipped because, I mean, obviously it would be flipped. There we go, 12 volts, looking good. All right. Next output, VSET, let's go 3.3, enter. Be down below. And 3.3, looking good. So I didn't use indicators in the buttons. And I'm surprised there's not individual discrete channel buttons. I mean, it would literally only be 2 more push buttons. All right, channel 4, we'll make this 7.253. No, VSET 7.253. And 7.46. Close enough, especially unloaded. All right, I'm satisfied. That is one working power supply. Okay. All right. Let's get ready to hoist it. Most people using through HPIB? Yeah. Yeah. The shelf of holding. I mean, I got a lot of test gear on it, that's for sure. All right. Yeah. There we go. It's very definitely a different color than the other ones. Whew. Okay, actually it matches that one fairly well. So that one's the oddball. Weird. The man on the shelf will know that it's got a metal spar right there. I don't like that so heavy and in the middle, but sponsored by Bend Back. All right. Let's pull that thing down. All right. Oh, it's so high up now. All right, let's turn that off. Move this out of the way, and then we get to play with fun stuff. We did our work. Now we get to actually have fun. So I'm looking forward to this. Just got to get the camera to mount. Just one moment. Fun. Okay, you're leaving. All right. Whew. Make GUI for individual dials for each channel. You would not believe how many people tried to tell me, cool, now you can set the outputs on the meters too with GPIB. It's like, yes, but I only wanted to read. What part about the visual overlay makes you think I want to try and set the outputs? It's a completely different use case. And having to go over to a computer and type and click versus going over to thing and button, 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 done. All right. Oh, I'm excited. Did I just read set the output via channel points? I don't think there is a more disastrous concept on the planet than that. Okay, we're gonna commit a little bit of heresy here, okay? We gotta mix HP and Tektronix for a bit. Just don't tell anyone. We'll all make it through this, okay? All right. Let's start down here. This is an HP 3325B, all right? This is a signal generator. More specifically, this is a dual channel signal generator. We have one output here and the other output way on the back where it's really inconvenient to get to. I might even call this a 2.5 channel signal generator. Because one thing we'll test here in a moment is that there's the main output. The main output is good from 0 to 20 megahertz, except unless you go over 20 megahertz, then there's like some other bonus one on the back that goes up to 60, but only for, I think, sine waves. It might be square waves. I'm not 100% sure. So I would like to try that. Is real cool. And what we're going to pair it with is just a straight up analog oscilloscope here, because that will let us do fun things. So we need 2 cables. Does this one do ARB? Yes, it does. So this is let me explain this. The main output is sine, square, triangle, and ramp up, down. So it's only those. The second output is ARB-Gen, but the second output only goes up to 10 kilohertz, but the arbitrary pattern is 4,096 sample points. So you can get a lot of bandwidth through that 10K. So I'm not that disappointed in it. Main output is basically mono, but the main output, so to help explain this, There was an HP 3324A, and this basically, it has literally a dip switch on the back to emulate that. And that was simpler and does not contain the second channel. The second channel is technically a modulation source. So you can route it back in, and then you can modulate the main output with it. That's what it's intended for, but it's much cooler as a second channel. So I'm gonna put this into channel 1, or channel X. And then we're gonna put this one into channel 2, or Y. And then we're gonna plug this around back into one of the billion connectors back there. I'm not gonna go into this too much for right now, at least. We might look at it in a bit. And then I'm gonna wish I still had a power cable over here. That's let me just go grab that one. And then I'll undo the one from that. Okay. All right. So, you might notice, especially once I plug this in and hit the switch, that's not an LCD. That's an LED unit. I very specifically did not want LED unit because they don't film well, except you can see this one kind of films fine, but we can see some minor flicker issues, especially when I move the camera. It's not perfect. LCD handles that better due to response times and just kind of how the panel refreshes and works. But it's not bad. Also, this was what they were still selling in 1997 as their like premier SIGGEN for like not RF stuff. So even though it's, you know, like an older design, it was still the one to get. So there isn't an LCD era one. There is actually a VFD one. They skipped from LED to VFD. I tried to get the VFD one. They're actually not ARPGen. So pass. So VFD is best. VFD is definitely good, but I wanted LCD for just going with one era. All right, so let's go over what we have here. This is an oscilloscope, and it does oscilloscope things. What we are doing here is we're gonna go channel 1. We're gonna set our input there. We're gonna wonder why this is seeming so weird. Is this thing boned? What's going on? No video capture on the scope. Not this one. I think I just heard a spring like snap inside, and now it doesn't seem so hot. The scope might be dead. I mean, I'm seeing the signal, but like, trigger source is channel 1. I'll do coupling AC. Oh, that's better. And we got a wave there. I'm gonna set the frequency to 100 hertz here. That didn't change anything. What? The output is on. Probes are, there are no probe settings. I guess there's a magnify, but the probe is a wire. So I think we're measuring basically noise there. That's 1 volt per division. That's 2 volts per division. That's 5. Is my scope screwed? There's a calibrator here. This is not the one that has the actual tech probes. So let me grab a probe. I will be sad if my oscilloscope is dead. The other really irritating thing is I was planning on bringing the BK2120 today, and then I was like, nah, I don't need to. I got the tech at the office. Why would I bring the redundant scope? Ha 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 ha. Ha. There are no rear inputs, by the way. That's not a thing. Well, that sucks. Yeah, I might as well zoom in on the scope, since it's going to be the thing that kills this. Dude, I swear we've used this on stream. Oh, that's not good. That's ground. Is this your old one? No. So the one you gave me is a digital scope. This one's pure analog. This thing's hosed. That sucks. Yeah, channel 2's the same thing. Focus would have to be like ultra super bad. The other thing is when I really zoom in there, if I get the trigger just right, let's switch back to channel 1. We can't actually see a wave. Sometimes. We mail you this 464. I don't really want you to. I do have another one. It's somewhere. Huh. I swear that someone did mention something about the buttons being a pain in the butt. Oh, wait. Hold on. Okay. There we go. So this switch is dirty. Whew. That's awful. The channel buttons are good. Oh my gosh, that was brutal. Okay. Back to SigGen. Click. That should be... Hold on. I don't think I can just pull this off. No, I cannot. This is super annoying. So I'm going to set the frequency back to 1000 on here. Okay, so that is in fact working. Oh! These are high impedance inputs. Well, that's not helping. All right, hold on. I'm going to try a ghetto solution. I mean, hold on. Amplitude. Oh, amplitude's garbage. 1 volt. Boom. There we go. Hey, I forgot. The amplitude basically starts out at 0. Okay. Beautiful. All right. Okay, let's have fun now. Okay. So on the deoxit or not, in order to get to the switches on here, you have to remove this front panel, and that's awful. It's truly terrible. So pass. Okay, so let's take a look at something here. All right. So we currently have a 1 kilohertz, 1 volt. Is that 1 volt? Why is it? This is set to 1 volt per division, but that's, you know what? We'll just pretend that doesn't matter. Okay. So we are at 1 kilohertz, 1 volt here, and we'd see nice sine wave. So you should only get 1 peak. Yes, that's true, but we're going to do this for now. What I'm going to do here now is I'm going to press mod source, and we're going to, actually, I'm going to hold shift, and I'm going to press frequency here. It's 1000. And amplitude, I'm going to set this to 1 as well. Now I'm going to go into XY mode. How do I do this? Oh, it's weird. XY, click right there. Okay. So in XY mode, we now have a line because we are having both traces go up and down at the same time. If I set the X frequency channel here, let's say to 2000 hertz, we should see a change. Huh, I thought that would change something. Well, let's set it back to 1 kilohertz. And let's do something different. Let's change the phase, and let's set it to be 180 degrees off. Okay, now it's just screwing with me. What? Oh, wait. Do I have to do add? Chop. Alt. XY or XY. Here we go. Okay, so this is how I do XY. Okay. Phase 0 degrees. Okay, you know what? Let's just, let's try channel 2 and make sure this is working. Amplitude 1, frequency 1000. Okay, why are you not working? Channel 2 coupling. Let me go. Let me make sure. Mod source out. Okay. And that's connected correctly. Need the sync out on the front? No, it's not that. Mod source is different. It is on the back. Just for giggles. Here, make sure it's... Yeah, it is the... Okay, it's the SIGGEN. What? Okay, there we go. Fixed. All right. XY. Boom. Circle. All right. There we go. We have circle. Yeah, I forgot you have to pick your sign, your wave type for the mod output. Okay, so you'll notice here that's now an ellipse because we set phase to determine the proportions. So that's 180. So if we set phase to 90 hertz, error. Why can't we set it to, oh, degrees? Okay, we're getting closer. I think I can just, yeah, there we go. I can step up and down. So we want 60 hertz there. All right. So we can do cooler stuff than this, okay? So we have our frequency set to 1000. I'm going to set this, we'll leave it at 1000 here. That's for why is the phases like coming out of sync? How is that even possible? You're on the exact same unit. Anyway, we have the frequency here, but this device does something else. So let's go back to channel 1 and this. Okay, so we have our wave here, all right? And I hit a button, and I regret hitting the button. I'm going to reset, and then frequency 1K. Okay, we have our phase here. So what I'm going to adjust here is I'm going to set this value to 1,000, or no, 1 kilohertz. And then I'm going to set this value to 1,005 hertz. Okay, so what I just did there is I set a sweep. And if I start the sweep, you'll see that this now moves. Where this gets cool is if we go back to XY mode, now the stop frequency here adjusts how fast it ultimately goes. So we can set this to 1002 hertz. And then we can adjust the time here. So we're currently at, is that 10 seconds or is that 1 second? Maybe it is just 1 second. So it's 1 second up and down. So we're going to set this to, let's say, 15 seconds. All right, 1970s CGI biofinal, yeah, did exactly the same thing in our school. Physics class was cool. Sensors like a bird just outside. All right, but we can make this even more interesting, okay? We're going to change our mod frequency to 2000 hertz. We can change it to 3000 hertz. I can also go out of calibration here and a little better. There we go. Digital ones really suck at that. Yeah, so Vionk, that's why I was trying so hard to get this thing working earlier. But yeah, this is ridiculous amounts of fun. Streaming went out of calibration. You see that? Great. Now you've emulated every 70s sci-fi tech display? Yeah, really. Do main is Sawtooth? We can. Here, Saw. Well, that's strange. Start. I don't know what's happening now. If I go back to sign. Oh, that's weird. What on earth? That's square. This is, whoa, okay, that's pretty cool. Let me, so it's bouncing off the side. So it's basically reflections. Huh. Here's ramp up. Okay, that's less boring. Oh, maybe I accidentally hit ramp up. Okay, will this make you go the other way? Okay, that's pretty cool. I love this because in your mind, this is what you think an oscilloscope looks like. Like if I'm ever gonna demo an oscilloscope, this is what I want it to show. This is way better. Yeah, basically, Philip, yeah. Okay, that's excellent. So if I do square here and square here, what do we get? Okay, just a wobbly square, okay. Oh, this might be better when it's slower. Hold on. Reset, start. Hold on, set time to 3 minutes. I'm gonna set frequency. Oh, I interrupted it. Now it's like some really extremely precise thing. Oh, by the way, this is addressable down to microhertz for resolution. It's ridiculous. To start, and then mod frequency 1 kilohertz. Oh my gosh, it's almost like it's plotting a trace, like a curve tracer. So back to sine. Okay. Ramp up. Ooh, that was pretty good. Yeah. Yeah, this is excellent. I like this so much. It's hard to beat classic, though. Do you have a frequency counter in your scope? In this oscilloscope? No. The 16500C, which is what I actually use as a DSO, just kind of sucks at it. The spectrum analyzer has counter mode. I know how to use that. How much time do we have? Do we want to try it with the spectrum analyzer? Wonder if it handles not having its oven removed correctly. Oh, maybe. Yeah. Yeah, watch this. So when I turn it off and then back on, it will say opt 1. It thinks it has it. Now, I should mention this, actually. Let me turn off the Tektronix. I'm going to move it out of the way here. I'll turn this off, too. We're probably done with this if we're going to go mess with the spectrum analyzer. Let me just get this off of here. Whoop. It should handle not having the oven just fine. So on the back here, this would be the external oven right there. This is the external input. So you actually needed a jumper to go from the oven to the input in order to use the oven. So it was never internally connected. So, and it's meant to be able to run without it. So as far as it knows, we're just not using it, but it's there. So I don't think it matters. Yeah. The spectrum analyzer works the exact same way, by the way. It has a output for the oven reference, but you can just disconnect it. It has an internal reference as well, and if we leave it on for like 10 minutes, it should say low cutout or something like that, and then it will switch over to the oven reference. So that's how that one works. All right, let's do a quick 100 ohm double resistor terminator thing here, so that we can actually try the thing. Although, do we need it? Way too much science for your old brain. Yeah, we'll just do this either way. Okay. To the iron, turn this on. Oven output, so it refers to a crystal oscillator in there that is heated to maintain stability, and it takes a while to get up to temp to be accurate. So you have to heat that crystal oscillator, and it just has its own internal heater, and then you can use that as a 10 megahertz reference. This unit was purchased with the option to have that, but it has since been removed, not by me. But the spectrum analyzer just comes with it standard. So, analyzer has 50 ohm input already. Yes, but that requires me to trust that the this thing is totally perfect. And let me put it this way: I am super duper ultra paranoid about the spectrum analyzer, and I don't want to kill it now. So just assume that. Like uber crazy, ridiculously paranoid now. Why is this not heating? Because I didn't turn the iron on. Is there a jumper inside to set option 1? I have no idea how it works. There is an installation manual. I don't know if it tells you how to install options. Why 2x, not just 150? Resistors and all electrical components like this are sold with a percentage of accuracy. So let's say you're the manufacturer of the ohm resistor, but it's not like quite 50 ohms, but you know, for most people it's probably good enough. Maybe it's like 49.7 or something, all right? You could sell that as a resistor that is X% accurate. You will have most resistors bend like that, and then you can maybe buy 10% precision resistors, which means that they're approximately 10% of the value if you measure them. If you take 2 of those and then you put them together, you go from 10% to 5% because you're having the amount of random variance in the binning of the resistors. So this will make this higher accuracy. And because there's two in parallel, we're sending current through both, so it reduces the resistance by half. So basically, it just makes it a better terminator. Well, it's not a splitter. A splitter's different. I'm about to use a splitter, actually. I'm about to use a splitter in a really horrible configuration. You just want me to mail you 50 ohm Terminator? I have none of them 1010. I will have some tomorrow, maybe. I just don't have any today. That's what it comes down to. Anyway, I need to connect this in such a way that I can use it, and now I'm about to commit crimes. So I'm going to put this T on the front of the spectrum analyzer, and then this is my Terminator. Hey, and then I can plug the cable in right here. And then that's my Terminator. It's perfect. Oh, it's a good idea to commit crimes live on stream. All right, let me grab the power cable here. Take this on over. So we are running this into the high impedance input on the spectrum analyzer because it can handle up to a 42 volt DC offset. I do not have a DC block yet. I will probably be getting one that is capable of going down to 1 hertz, which is lower than the floor of this spectrum analyzer, so it will be perfect for it. But until then, we're not going to use the 50 ohm terminated one because I do not want to risk it. Because I want this thing to live forever. It's made it this far from 1979. I'm not going to be the one that kills it. Our crimes are basically magic crimes. Okay, hold on. Let me move the camera. This time I actually need to. We're not going to have long to play with this today, just letting you know. No jank whatsoever. I gotta tell you, it's not going to be a whole lot better once we get the actual Terminator. The only problem is that one is the wrong gender, because I just didn't have that. Okay. 6 whole minutes, yeah. Yeah, we don't have a ton of time for this. All right. I'm plugging this in. Let's go here. I'm going to unplug the mod source output on the back. Don't need to actually. I'm going to leave that out and just drape it over. It's so stupid that the second channel is on the back only. I don't need that dumb sync output. Give me the second channel on the front. Jeez. All right. Okay. Because I moved everything out from under the bench. I don't have anywhere to stand one over there, so give me 1 second. There we go. Okay. All right. Flip this so I have an easier time reading it further away. Make the font slightly bigger. Okay. And boom. Analyses time. Okay, so I'm going to turn this on, turn this on. Remember that I unplugged that? Turn this on. Turn this on. There we go. Okay. And it's already broken. Yeah, no. Okay. I am going to be super, ultra, ridiculously cautious and annoying about this. Our programmer, I am clear and safe to plug this into here, which is the 1 meg high impedance input with the 50 ohm terminator on the back, right? That's safe. I'm not going to kill it. That's the only thing I think I need approval for here to feel good. Yes, okay. Let's do it. All right. So this is the full 40 megahertz span now. We are not overloading. We are in auto range and auto reference level. What we're going to do here is we're going to set the center frequency. So we're outputting 1000 hertz, but at like no amplitude. So I'm going to set the amplitude to 0.5 volts, 0.5. dB. Let's try that. Okay. It is auto ranging, and I think it's happy. Now, because this is less than 300 kilohertz, it is going to be almost invisible. So we're going to set the frequency span to, let's say, 20 kilohertz. All right. And I'm going to set the center frequency to 10 kilohertz. And right there is 1K. So what I can do now is I can go to counter. Oh, no, I'm going to go to marker. I'm going to move the marker over to this peak, which you guys may barely be able to see. All right, so we have the peak there. I'm going to peak to center frequency, or marker to center frequency. Shear span limited, that's fine. We're going to set our span here, frequency span, to, let's say, 5 kilohertz. All right, we're getting closer. Now I can go to counter here, and when I get to the top, it should see it, or start to mark it as the value. That's weird. Oh, I think I have to leave it and let it do it a couple of times. There we go. 1000.1 hertz. Set it to 500 and stop at 10 kilohertz. You should see some harmonics. Well, I think I should fix some of the... It's a shame we're using the 1 meg input since the other one is better, but I don't want to mess with it until I get the terminator. Yeah, let's set it to... Let's set this higher, actually. So let's set this to 10 kilohertz. So 10 kilohertz. That peak goes away. Right? Frequency. What did I just do? 10 kilohertz. Okay, that goes away. Amplitude. Oh, I did suboptimal things. Never mind. Oh, I set it to 10 millivolts. Okay. Thank you for being not insane here. 0.5 dB. Okay. So let's set start frequency to yeah, actually no, hold on. How do I go back? Start frequency 5 kilohertz. Stop frequency, we set this to 10? Yeah. Stop frequency 20 kilohertz. So we should see it right in the middle. My sweep time is outrageous. What? Why is it right there? It's automatically calculating the sweep time, by the way. If you set the generator to square, you see more stuff. Huh. I don't know why I'm not seeing more harmonics. So they say you should set video bandwidth to 1% of the resolution bandwidth. 1? And now the... Maybe resolution... Why is that such a ridiculous sweep time now? Maybe 100 here, and then 1 There, out of range. 3. Step up, down. 86 minutes for a sweep. Oh my gosh. 300 hertz, 0.6 seconds. Okay. Why? Okay, hold on. I'm going to frequency span, just go up. I think that's a harmonic. It's a generator on sine. Yes, if I could set it to square. Whoa, that was crazy. Those are way more. Way more stuff, huh? That's nuts. As far as a lot of harmonics, yeah, I guess so. Sine should have no harmonics if it's perfect. It might be good. One of the examples in the manual for this thing was HP measuring one of their own, oh gosh, it was like an oscillator source that I think was supposed to have a 90 dB harmonic cutoff, and they measured it at 97 dB because they were being all fancy. But they did measure the harmonics, so there is probably a harmonic for sine in here. I just don't know how to measure it. Or that might be a harmonic. What's that frequency span to 25 kilohertz? So maybe there. I think if we were using the 50 impedance, 50 ohm input, that might clear up. But I'm guessing that's one. Can it do averaging? It can do max hold. Where is it? Max hold. Well, that looks terrible because it, hold on. Disable the automatic reference level and auto range. Oh, now we're on, hold on. There, okay, max hold. So, yeah, we can kind of see it there. Looks like second harmonics at 20 kilohertz. Don't forget, vertical scale is logarithmic. Yes. Yeah, we can go counter here as well. And if it hadn't just distorted a whole bunch there, yeah, we can see 20 kilohertz there. Ooh, this is fun, too. Let's say we max hold. We let that accumulate. Stabilize out. We can do store A to B. That copies the current view, and we now have 2 traces. So it's double drawing, but we have essentially 2 registers here, and if I don't remember what I can do all here, so I might be able to adjust the frequency span, I'm not sure, yeah. So there we can see we're drawing 2 sets of waveforms at once, because we have one of them saved in memory, and we can review that. So basically you can screenshot and hold that value and then view it. You can also do A minus B. So if I figure out what the zoom level is here again for this. So here we're not seeing the second harmonic because it's ranged weird. And if I do A minus B, we'll see the difference between it. This thing's cool, man. It's really cool. Another thing we can do here, actually, let me get rid of the B view. Okay, so we were looking at that harmonic. So 50 kilohertz. Another thing I can do, I don't know how visible this is going to be. You know what, I'm gonna try and zoom this in real tight here. Oh man, I could have done that. Now you guys would have been way happier if I'd done that before. Let's say I want to know the value from one peak to another. So what I'm going to do is I'm going to put the marker right up top here. I'm going to go into counter mode. It's going to counter. It knows that it's 10 kilohertz, okay? Then I'm going to go into offset, and then I'm going to enter offset. Then I can put the other offset over here, and it now knows that there is a difference between this peak and this peak of 10 kilohertz. I'm going to go ahead and re-enable auto ranging as well so it stops overloading. But we're able to count the difference there. Can you change RBW to 100 hertz? Resolution bandwidth to 100. Yes. But it makes it ridiculously slow, so I'm going to have to adjust the video bandwidth to make it... I mean, then it's 10 hertz at most. There we go. Never use a spectrum analyzer for sub 100 kilohertz signals. Or past 4 hours. I know. I know. Yeah, there's so much. So this thing is really cool. I'm so glad. Oh, third order harmonic there too. Ooh. Yeah. You know it's a good display because it's electrostatic. It's excellent. Oh man, I'm really, really happy with this thing. This thing's so cool. There's another interesting thing we can do here, actually. I'm going to go to manual sweep. I'm going to clear A. All right. I'm going to clear offset counter. I'm going to go to marker. I'm going to clear A one more time. I'm going to go to 10 kilohertz. I'm going to go into counter mode. All right. It's going to find that. I'm going to manual sweep 1 point there. Then I'm going to go back to marker. Then I'm going to go over to approximately 20 kilohertz. It counters in, and then I can manual sweep there. We have now just taken 2 sample points on this reading. We only have the 2 points that are actually stored. We have manually swept the signal. One of the things you can do with this is we can get high narrowband measurements this way very quickly. This would be really helpful with GPIB programming. Let's say you are working on a filter and you don't need like ultra high precision. You could do known programmed steps, and then you could just check those values and go through it super fast. So ASWAR, this is literally FFT hardware, essentially. That's what it does. So does it have a print option? Yes, it does. I can't use it. I really want to, but I can't. Cause I need an HP 8035B, or is it a 2035B? Hold on one moment. My fingerprints don't work anymore. HP 2035B. No, 8035B? Maybe I have the model number completely wrong. I have the model number completely wrong. It needs to be an XY recorder. It's not a printer, not a plotter, XY recorder. We could also connect it to an external monitor over one of the connections that it has on the back and just have like the display up there, but I want an XY recorder. Really, really bad now. Like super duper ultra crazy bad. Anyway, this thing's awesome. I really, really like it. I'm super happy. So yeah. Anyway, it also has to be the HP rebrand of the Mosman model, the first one, not the cost-reduced second gen one, because it needs to be the original higher, faster one that has better slew rates. Can you measure the level difference between fundamental and first harmonic? You can measure the amplitude distance or difference. I don't remember how to do that. I would need to look at the manual for that. I know it can. I don't remember how. Counter, offset. Or does it just tell me? Hold on. Let's try this. I'm going to disable counter. Go offset. Enter offset. Hold on. Let me change the marker. There we go. 65 dB difference, I think. There we go. There's the amplitude difference. I have an HPXY plotter. You'd have to look at the model number. Yep, Wizard Ted got it bang on with the graticule. The manual says many times that the actual divisions there are not calibrated and that the computer inside has no way of knowing where they are, so don't rely on them. Oh, man, this is so cool. Anyway, there we go. We got to play with it. I'm super happy now. I spent like 3 or 4 days this week tearing through the manual for this stream so that I could actually know how to use this thing. It is so cool. All right. We are going to have to call it there, though, for now. Oh, man, that's so nice. All right. Whew. I'm much happier now with where I'm at with that thing. Learning how to actually use it. So, yeah, we ran over a little bit. It was worth it. So, then you decided to rebuild power supply for 3.5 hours first, so you have your priorities straight? Yes. Well, I mean, I had to, or else it wouldn't have happened, because we would have been doing that all day, because it's so cool. So, Vio, when I say computer inside, it's just a custom internal computer that runs it. I'm gonna guess it's a Motorola 68K. That's what's in the signal generator. It's what's in the HP Series 200. HP liked the 68K a lot, so I'm just gonna guess it's that. But any computer that can interface over GPIB could control that thing. So, yeah. Oh man, I'm happy. All right, we're gonna wrap that up again. Seems a bit late. Okay, maybe it's not that. Maybe it's Capricorn. I don't know. But yeah, I am not tearing into it because it works, and you could not pay me enough money to make it not work. So, oh, it's what it was originally intended to be used with was the 9825. That if you read through the manual, that's what they want you to program it with. But yeah, I was gonna say I wouldn't be surprised if it was something in-house at that stage. Yeah. So, but all right, let's run the outro. Well, thank you all for being here for this stream. This one was a lot of fun there in the last 20 minutes. We got the quad channel power supply working. I'm really happy about that. Don't have to worry about that one anymore. Both the spectrum analyzer and the signal generator do not have REFAs in them at all, so they don't need to be removed from that. Yeah, it's very, very complete now. Oh, I will say, I think I mentioned an LCR meter by HP could be a thing. I don't think that's gonna happen. They're super duper expensive to get with GPIB. I don't know why. I think it's because Keysight still sells the same version that is like the one they made in the 90s. They've not updated it. So I think it's still current. Cause like the LCR meter you can find in the 1997 HP catalog still sells for like over $500 on eBay. So yeah, we're not doing that. We're gonna use the DIR-EE handheld one. Yeah. It is 4-wire LCR meter, but it looks like it's to get an HPIB one, GPIB, whatever. Yeah, it's got to be that. So anyway, I'm going to acknowledge that I could raid Majenko, but I am not set up to do that right now. Yeah. But you guys could go watch Majenko, who is one of the mods here. They are streaming now. If you guys want to, I don't know how to give a shout out. Yeah. All right. Need to make friends with a Keysight rep. They'll pretty much mail you anything for demo. I don't want it for demo. I want to own it. I don't want it to have to go back. That's why I own all of this. Anyway, that's gonna be it for today. No stream tomorrow. There will be a stream Sunday. It's probably gonna be more GPIB programming stuff because I don't think I'm gonna be able to stay away from that. I think I need to spend a little more time with all of this stuff, so we'll probably look into that. But that is going to be it for now. So, oh my gosh, T2, SDE, and Raiders, hello. I'm gonna just quickly restart the outro thing here. We are just ending. I just finished messing around with an HP 3585 signal analyzer from 1997 here. I was using a 3325B signal generator to mess around with it. But yeah, we are in the outro here. Yeah. All right, you know what? We'll do this. We were Ethernet garbage. Oh no!